Well, it's a pleasure to be here. In case I don't want to forget, but thanks to Jordan for putting this venue together and then giving myself a chance to speak. I enjoy sharing knowledge. Let's say that first and foremost. And I think I'm not any smarter than anyone else in the room, but it helps to be old, and so I think experience counts. So don't count me out yet. I have a few more things to share. Okay, I did take a few notes here that I'm going to refer to just briefly, and then I'll set that down because I think these comments are very important, and I didn't want to forget them. I'm going to talk about the ideal system. Well, what kind of system? A CMMS system, some might call it, but actually I prefer to call it an asset management system for the CRLs that are in the room. Can I get a show of hands of CRLs? Okay, there's other accreditations, CMRP, SMRP, CRE, and so on and so forth, and those are all wonderful. Okay, so again, I'm going to talk from a asset management system, but from a CMMS perspective, because really, I'm just a CMMS guy. So there's two worlds. Can I stand up here? I don't know. Does this work? I think there's two worlds. I started out in the CMMS side, put that down, and 15, 20 years consulting in that arena. And then somehow I got introduced to the reliability world and meeting professionals like Dr. Penrose here, and Terrence O'Hanlon, and then Nancy, if she's here, okay, and then and many others. Charles Latino, if anyone knows that name. Winston Leday, do you know those names? Okay, I'm going to talk about them. And I need the clicker. Where's the clicker? Okay, good, no worries. And so I'd like to believe that I'm a student of asset management. So even though at my age I try to learn something new every day, we talked earlier yesterday and maybe this morning about the term benchmarking. To me, I could talk all day about benchmarking. I have my own definition there, and benchmarking is an ongoing search for knowledge, as I said. So I'll look for, I think Alan Ross wanted me to say the word comparative or comparison knowledge seeking, but really to me it's just looking for knowledge anywhere I can get it. If it's in the newspaper, the internet today, I didn't have that 30 years ago. You guys are so lucky. And the trade magazines, reading books by various people in here, attending venues, the wonderful people who put these things together, listening to these presentations, that's how you learn. And I attended a reliability web venue one time, and I'm being the CMMS guy, I checked off the agenda there, make sure I want to listen in on all of these subjects that I'm more comfortable in. But Terrence O'Hanlon said, well, I want you to be a monitor for this other presentation on a subject I had no interest in at all. Well, come to find out, that subject is at top of my list now. That's defect elimination. And so I was forced into a subject matter that I didn't really care about. But so every day I'll wrap this up by saying, it's amazing how much I don't know. Yeah? Okay. All right. Well, here's a bunch of did you know questions. So everyone in here, who does not have a CMMS currently in place? All righty. Maybe you're looking for one or maybe not. Okay. Believe it or not, there are some sites that track all of their asset data just on access. Someone mentioned that earlier. You could do that. Let's talk about that conversely, that subject, right? So here's a customer that's got $1 million asset management software package, and I won't name the name, but they've got $1 million invested in this thing over the years, and all they're doing is tracking work order tickets. Okay. Yeah? This is happening. Or you've got leadership that says, we've got the $1 million software package, but you know what? We don't trust the workers. I want to bird dog their hours, their wrench time. I want to track their productivity. And that's all they're using the system for. What a misuse of the product. So one of my major themes is going to be failure analysis, especially chronic failure analysis. And so recurring is synonymous with chronic, right? So recurring failures. We just talked about root cause failure analysis, but how often should you be doing that? Maybe once a week, more likely once a month. If you're doing it more often than that, you've got bigger issues and you need to reevaluate your thresholds, perhaps, maybe, I don't know. There's just so much work you can do in a given day or week or month. And you want to, like this term, management by exception. Yeah? So you don't want to go home in the evening and lose sleep over what the heck you didn't do or did do. And you want to do the best you can by focusing on the worst offenders. And if you have that process, belief system in place, you can sleep easily. Yeah? Manage by exception. All right. Did you know 70% of all sites in the world using whatever product, I don't care which, have never successfully performed chronic failure analysis? The most significant, in my opinion, tool you can have to reduce O&M costs. Not RCA, not even condition-based monitoring, perhaps. Chronic failure analysis. Okay, and we're going to discuss that. By the way, I'm talking for 1 hour, 45 minutes this evening here, but I'm also going to continue this dialogue tomorrow morning. Won't you be lucky? Okay, all right. There's a lot to be said, of course, on this subject. Okay, scheduling. So did you know you could have 100% weekly schedule compliance, but be doing the wrong work? Okay. All right. Did you know that you could have a world-class condition-based technology program, but every 6-9 months after the event, you discover that a problem again on the same asset, and then 9 months after that moment, you discover it again. You get quite good at detecting this failure, but no one ever really dug into the actual cause, the human factor part perhaps, and therefore the lack of lubrication is causing this problem to reoccur. You got real good at replacing the bearing though. Okay. What else do I got here? All right, I'm going to talk about, remember now, I'm a CMMS guy, and I stepped into your reliability world. So I'm not really a reliability engineer. I wish I was. I'm really appreciative of that knowledge in the maintenance managers. Okay. Are you aware that the CMMS guy does not know what a failure mode is? The language is very important. The words are very important. So they will say failure codes this, failure data that, failure history this, but failure mode is the language of RCM. And if you did a 2-word search in whatever software you're using right now, online help, failure mode, hit the enter key, you'll get no hits. The people who designed the product I use 28 years ago, whatever, never read the book from Mowbray. They never read any concepts on RCM. They got this failure code hierarchy designed down, but failure mode is not a concept that they understand. Now, prove me wrong. Someone tell me if they've heard differently. But you know what we should start doing? I'm putting myself in your group of reliability professionals, if you let me. But what we should start doing is inviting the CMMS guy, bring them with you to these venues. This is how I got enlightened I stumbled into the world of asset management, and I was amazed at how much I didn't know. Because I was pretty big on myself being the CMMS guy. I hadn't met anyone who knew more than I did on that subject. But earlier, either today or yesterday, someone showed a slide showing the uptime elements, and there's 36 of those things, little boxes, right? Very colorful picture. But the CMMS is only one of them. So 1 of 36. All right. Sometimes when you you look at the marketing brochures or literature, you will see a sentence or statement that says, if you implement this software, you will improve reliability 25%. Okay, well, that ain't gonna happen. And furthermore, they should never be saying that. That makes me angry, okay, when I see that. Okay, or something similar, they'll say after you go live on the brand new CMMS package you just installed, you will improve by 25%. What I've discovered is that's not true either. So what I've discovered is for most organizations, it's only after you go live, open the champagne, the consultants leave, that you really get to learn how the software is used, and then maybe you start attending venues like this from Jordan, and you acquire more knowledge as to how a system should be designed, and then that's what that's the wrong button, and that's what we're gonna discuss. Okay, so recurring failures, I'm gonna get on topic now. Recurring failures have a cost. And it's important for organizations to seek continuous improvement so that they can improve operations. And so the number one problem and opportunity is that huge amounts of money is being spent every year by operations and maintenance to run the plant, run the facility, and 80% of these dollars are spent on chronic failures. So if you remembered one word out of this entire presentation, it's the word chronic, which is recurring. Now, that's not my quote. That actually came from Charles Latino, who has since then passed, but his family name is still in business and out there. And this is a concept that they discuss quite often. What I have done is taken the concept and put it into the CMMS design model. That really is the gist of my entire presentation. So, okay. And I'll be talking about defect elimination also, a little bit about RCA, RCFA, and work order feedback. Okay. By eliminating chronic failures, we can reduce maintenance costs between 40 to 60%. Doug, as a maintenance manager, do you care about those numbers? Should that stick out in your memory? 40 to 60%? That's a big deal. Okay. So if that's true, shouldn't we as reliability engineers, maintenance managers, focus in this area? I would hope so. But the sad point is, the majority of all organizations, let's put a number on it, maybe 90% are unable, this very moment, to extract a bad actors report from the database. Now, is the gentleman here, is John Langskoff still here? No? Okay. Well, the nuclear side, nuclear industry is doing pretty good, and he would probably say, well, hang on, I can do that. Okay, fine. But the majority of all other industries struggle in this regard. And I'm talking about the software that the organizations that are using the software that I consult in, that they also struggle to do this. And so again, what have you done? You've got a work order ticket system, but you're unable to extract bad actors. Well, that's sad. All right. 3 principles of reliability. You want to prevent a failure mode situation. You want to discover potential failure modes, of course, and meet regulations as required. Chronic failure analysis may be the most significant process within a reliability program. Poor reliability is a result of unplanned breakdowns, potential collateral damage, higher cost to repair, higher probability of personnel injury, safety and reactive maintenance, potential HSE and public relations impact, break-in work, and excessive redirects. The term redirects, are you good with that? That's where I'm following a weekly schedule created by the CIM software, and I get a phone call from Doug here, Doug, the maintenance manager, and he says, John, get your ass out of there. Come over here. We have a fire going on, and you need to put it out. That's a redirect. Too many redirects can cause problems. Okay, so there you go. That machine is telling you what to do, as opposed to you in charge of the assets. So here's the uptime elements, 5 verticals, 5 wonderful colors there. The CMMS box is what I'm focusing on, and I happen to believe it has a significant impact, if you let it, on reliability engineering. If you let it. You have to know how to configure the system. You have to know how to set it up. You've got to have a plan. How should we set it up? Should we just use it as they gave it to us out of the box from the software vendor? I hope not. I hope you can understand that there's a bigger purpose and potential here as a result of this presentation. So, reliability engineering, I'm focusing on chronic failure analysis, and let's see where we go. Now, what is the benefit? Well, a CMMS, again, the brochure will say, well, we'll improve reliability, but that's not in this paragraph that I've written. Yeah, you're going to make electronic work orders, which is better than a paper file cabinet. I'll give you that. Fine. You're going to be able to link work to assets or locations, create a standard job plan library, template, whatever, with standardized steps, get the safety precautions in there so everyone works safely. You'll be able to link it to inventory as reorder points are reached. It will automatically create a purchase requisition. Isn't that nice? Okay, fine. And then convert that to POs. And then three-way match with the invoicing. Okay, fine. Auto generation of the calendar-based or usage-based PMs. That's a wonderful feature. Fine, assuming you're doing the right work. Capture actual costs. I've had let's say it this way. I've run into maintenance directors, O&M directors, very high up, that say, hey, we've got this software. I know how to produce a bad actor list. We'll just, on a monthly basis, we'll run which asset has the highest costs. So regardless of the asset in the system, that's their idea of how to identify the bad actors based upon total cost. I'm not sure that's a good approach. Yep. Because some assets just demand a larger amount of attention as opposed to smaller ones. But it's a smaller one, if it's a high risk, high criticality asset, it deserves certain actions even though it's not as much money. All right. Failure coding. Majority of all sites, well, the implementation teams, they got a list of things they want to do. They need to load data, set up the failure code, the equipment location hierarchies, fine. Load the item master table, set up company records, GL account codes. But for whatever reason, they put off building the failure code hierarchy. Why is that? They went live with that thing not totally built, or it is built, but they didn't turn on enforcement of the procedures. Why did they put that off? The answer is, very simplistic answer, it's hard. They don't really know how to set this up in a failure code hierarchy. Maybe the design of failure codes inside a hierarchy is flawed by itself. All right. So the CMMS here on the left, but let's start talking about an asset management system. So I mentioned earlier I differentiate between failure codes and failure modes. Here I'm differentiating between a CMMS and an asset management system. An asset management system consists of three pieces: software, data, a process, procedure, and roles, responsibilities. Reliability Web, Terrence O'Hanlon has taken my simplistic three-point definition and made it into 36 elements. Fine. Okay. So an asset management system involves leadership, aligned goals, risk management, RCM-based maintenance tactics. Wouldn't it be great if you could link of each of your maintenance strategies in your PM application back to the failure mode you're trying to mitigate? Well, who's doing that? Well, that's a best practice, if you can figure that out. I do discuss that, by the way. Precision maintenance. Anyone here ever bring in an outside organization to conduct precision maintenance training for their staff? Okay, thank you, Mike. So have you, Chuck, so have you heard of that, anyone else heard of that term before, precision maintenance? Thank you, all right. Yep, induced failures, so you need to pay attention to the skill sets and make sure they're doing the right things when they're performing the PMs, because that's when you can induce some of these failures. Then you get into a vicious cycle. All right. Okay, so you have whatever software, CMMS. There's like 9 or 10 ways you can utilize this software. And it starts out bad and they get better. So the first one I already mentioned, which is we simply want to track work orders in a formal software CMMS package as opposed to a spreadsheet. Fine, that could be your purpose objective of this product. And that type of statement, management has to pay for this thing, right? And so in that scenario, management said that's all they want to do, and they're the ones who made the decision, and by gosh, by golly, that's what you're going to do. You're going to make work orders. Or option 2, we want to track actual costs. I said this a moment ago because we need to know the total life cycle costs on any asset at any time. Number 3, we want to track our wrench time because, quite frankly, we don't trust the staff that's working for you, Doug. They could be out there smoking and joking. We want to track their work hours. We want to capture actions performed. Now, I love this one. This is actually a good thing. So, who knows what this is right here? Multi-tool, made by various vendors. The one I'm thinking of is in Portland, Oregon. Okay, so, yep, I went there for a while, and one of my first observations was they're using the software that I consult in. The first observation was the maintenance guys were doing things on their own because they felt it was the right thing to do. I'm going to say that conversely. There seemed to be a little bit of a loggerhead going on between management and the trades. I don't know why. So they didn't trust each other, the wrench time thing, tracking. But the trades, in spite of poor leadership, wanted to track actions performed. Why would they want to do that all on their own without being told by Doug? Whoever answers this can go home early today. Sorry, Doug, one more time. Craft learning, and that is the answer. So, someone else had, who said what? Okay, so craft learning. So as the trades, professional crafts, if they store actions performed as a rich body of text in a long description or log field, whatever, doesn't matter. The next time Sean comes in here and by chance 6 months later is working on the same asset, he can do a query on all work orders for that one asset, and up comes the list. And Sean, is that going to help you? You darn right. You're able to read the text on the last repair event, or even know when the last PM was done or skipped, because it was canceled maybe, and that's right there. So with or without management's leadership, you're creating a system to help yourself. You get points for this. Unfortunately, we can do better. All right, now, Sean, I'm going to promote you now. You're now going to become a reliability engineer. As a reliability engineer, you don't have time to be doing that same query. You don't have time to be printing each work order and reading the text, or even online, you know. You have to be smarter about this and run a report or an SQL command that will tell you what the bad actors are and produce it in a nice, concise list of top 3, top 5, top 10. Push a button, run the report. 60 seconds later, it's right there on your screen. That's how you, as a reliability engineer, need to operate. Now, this is where I deviate from everyone else in that most people, if they're lucky, will be able to run that top 10 bad actors list. I take it one step further in this book right here, Failure Modes to Failure Codes. Okay, who wants to be plant manager? Doug, you're now plant manager. All right. He's the reliability engineer, and he's walking into your office, and he says, Doug, these are the top 10 bad actors. In fact, the top 3 on this list have been really causing this havoc. You look at the list, you look up at Sean. What do you say back to him?
We're going to do better.
Okay. All right. That's okay with that answer. I'm looking for a slightly different one. This number 1 asset, who might have a different answer? A question. You're the plant manager now, and don't let Sean off the hook. You're going to ask him what?
What's it going to cost me? What are you going to do about it?
I like that one. I'm going to ask him why. Why is asset ABC123 the number 1 problem asset on the list in our plant? And I'd like to have the reliability engineer provide that answer. Now, he or she may or may not be able to answer that right then and there, but through proper design and configuration of the system, we can track failure mode data on the work order. And that's a secret. For people in this room, do not share it with anyone else. Okay, being silly. Through proper configuration of the system, I'm repeating myself, you can track failure mode granularity on the work order, but you got to know how to do it. All right. So maybe I connect all the dots here. I don't know. So if the plant manager asks the reliability engineer, why is that asset problematic? You could then say, this is a pie chart showing our dominant failure modes. And if it was on an overhead screen and you're in a reliability team meeting, you could dynamically click on the largest wedge and it would show a second pie chart showing the problem of the component, the failed component. And a third pie chart would get into the crosscodes. I'll get into that tomorrow. That's more involved. We're only on number 4 here. We want to capture basic failure codes. I was at a power plant, coal plant here 15, 20 years ago, and their idea of capturing problem codes, failure coding was mechanical problem, instrument problem, electrical. Well, for the reliability engineers that are in the room, and I've talked to a few of them, that won't help you at all. There's no valuable information there. Okay, functional failure. So you have a repair work order on the screen. You're looking at the work order and you're staring at it. You read the problem description, but is it a functional failure? Okay, there could be some algorithm that says if someone reported a problem, by definition, it's a functional failure. I'm not sure you can get away with that all the time. Or someone might say, hey, we have operational downtime, therefore there's a functional failure. That might be more likely, but here's the deal. Unless you've got SCADA system in place hooked up to these assets, you don't have the data in the CMMS to tell you that the machine actually went down. Majority of all sites using the CMMS software do not capture downtime, even though a downtime event occurred. Am I saying anything that's shocking here? Okay, the software you bought cost you $1 million, Sean, but you're stabbing yourself in the foot in the way you're using it. Okay. Functional failure. If you are able to configure the screen, you can add a field in 60 seconds, a yes/no field, titled functional failure. So the tech, when he's completing the work order, he would answer the question, or whomever, row-wise, and they would mark it yes or no. Default to no, but he would have to physically flip it to yes if there was a functional failure. Now, maybe Doug's thinking, hey, John, hang on a moment. How does he know a functional failure occurred? I'm going to ask you a personal question now for your facility. Would your techs know if a functional failure occurred? Some would. Okay. So whenever I get into this conversation with the customer, I am a consultant, they will start thinking heavy and hard about this subject, and they'll say, well, how do we know a functional failure occurred? Well, maybe you should have a long description somewhere on the asset that says these are the functions that are intended by this asset. If the pump is supposed to take water from this tank and deliver it at a certain pressure and level to this other tank destination, that becomes your criteria. If you could capture that digitally and store that as a long description, then therefore that's readily available to answer the question. If the trade doesn't actually know if it's a functional failure, then go up the chain of command, ask the reliability engineer, ask the maintenance manager for his help on deciding the question. If you do not have the functional failure marked on a work order in some way capacity, you're going to have a hard time producing the mean time between failure metric. We've been talking all day and yesterday about mean time between failure, mean time between failure. Well, show me the SQL for that if you don't have functional failure. Remember, I told you don't have downtime either. As reliability professionals, I'm asking you to start thinking SQL just a little bit. If you walk up to your IT guy and say, hey, help me build the mean time between failure metric, he's going to give you a blank stare coming back at you. The only people who can solve this problem is you. You have to take the initiative and start anticipating what is it you want out of the system and make sure you have the fields on the screen and the processes and the roles in place, software process and role, to make the system work. I hope some of this is sinking in. Okay. Identify bad actors, I hit that subject. Dominant failure mode, I hit that. And work order feedback. The product I use does not even talk about work order feedback in a formal manner. You can have a hallway conversation face-to-face, and one of your trade supervisor says to you, Doug, this is a recurring problem, and I think it's a design flaw, or it's a maintainability issue, or it's an ergonomic issue. You know, whenever I got to take the reading on top of this, from this gauge, which is high up on the tank, the only way I can see it is if I step on this pipe here, which is surrounded in lagging. You don't care if I step on the lagging, do you? Okay. All right. Let's move on. So, what might be the primary benefit of a CMMS in support of reliability? Anyone hazard a guess? The answer is failure analysis. So leverage the software to make database decisions, so you can identify the bad actors and identify the cause. Now, once you identify that this particular asset is a bad actor, what are you going to do about it? Okay, well, if that question is asked of me, I may go back and look at the individual work orders, the repair history, even the PMs that are involved, and do an analysis there. Maybe if you ever had an RCM analysis, you might discover that a particular failure mode that was on the work order that was not in the RCM analysis, so that might be an observation. The operator operating the equipment is routinely operating outside allowed thresholds. Yeah. Or the operator, before the start of the shift in the manufacturing plant, is supposed to check the filter or even clean the filter before he starts, but he's not doing it. Or the maintenance guy really doesn't have proper precision maintenance skills. Maybe the supervisor that picked the person to do the job matched up the wrong skill set to the job complexity. I don't know. And you might want to start applying condition-based technologies, Chuck. If it's a critical asset and it has recurring problems, you might apply more than one technology, ultrasound and vibration and whatnot. Okay. So here's a slide talking about failure coding versus failure history versus failure analysis. They all sound alike a little bit. Scenario 1, if things break, we fix them. Scenario 2, the trades maintenance group is saying, we're deep in the reactive maintenance. Don't be wasting my time with doing a lot of updates on the work order in the CMMS software. I'll say it's done. I'll give you actual hours, but that's it. The maintenance engineer, this is a company I was thinking of many years ago I visited, whereby they maintain all the failure history in these little blue books. So obviously that's outside the computer system, but it was quite handy as long as the blue book was within arm's reach and you weren't in another building when you needed to see it. Yeah, all right. Reliability engineer, well, yep, we talked about that, and yep, data science. All right, failure codes is a high-level term for problem, cause, and remedy. Failure mode is the language of RCM, as I said. It consists of a failed component, a component problem, and a cause code. How many components could you have in a given asset? 10 minutes, all right. Hundreds, maybe. All right. What's the rule of thumb? If you have a choice list on a field and you click it and it shows a list of things, what's the maximum number that should be in that choice list? 15, maybe 20, somewhere like that. What if I said I can have a list of components and it's got 500 entries in it? How the heck would that work? There's a feature in the software that we use, and it allows what we call a type-ahead buffer. This is a perfect case for using that, deploying that feature. If I had a keyboard in front of me, I could hit one character, hit a second character, and a third character, and out of that 500 list, I'll then be looking at 12 choices. It's that quick. So just be smarter than the software, and that's how you can manage the failed component list. Now, if the component is not there, I have a field to the right of it that says missing component. So you leave the component field blank, and you tab over here to the missing component field and type in, what do you type in? You type in Ooga Booga. You save the record. It's electronically routed to Sean, and the next morning he comes in, and he reviews it, and he says, yeah, Ooga Booga is a good value. It's not in the list already. There's nothing similar to it. I'll approve it. He approves it. The software comes back and automatically updates the work order with the right component and adds it to the component list. All we're saying is make the software work for you. And this is how you could design the system. Business rules. Okay. Definition, actions performed, failure data, functional failure, asset management system. Fine. Okay, failure data. Let's get to the good stuff. So we could have the world's most powerful asset management system, software package, in our left hand, but if the culture is not in place, it really doesn't matter, does it? If the trades or the supervisors or whomever are careless about the entry that they're performing into the system, they're choosing the wrong asset, they're leaving the asset field blank altogether, well, that's really going to screw things up. And if the data is corrupt, it won't matter what scheduling software you're using. No advanced product will work properly with bad data. You could do a search for CMMS data quality on the internet, which I've done several times. And you see people, reliability professionals, talking about, well, your data sucks. It's bad. And because it's bad, as a reliability professional, I'm never even going to bother recommending people waste their time looking at it. It's all it's good for is capturing work order tickets. Let's be honest. And maybe that's a management decision, and therefore you've got whatever you've got, but that we're not going to use the system for this. I'm going to summarize this evening by saying chronic failure analysis is not root cause analysis. A root cause analysis might take a week, maybe longer. Yeah. A chronic failure analysis is you're the reliability team, you have a monthly meeting. You've got 7 people in the room. You run this failure analytic I'm going to show you tomorrow. It comes up on the screen. You're looking at the top 10 list. Doug says, click on the first one. Sean clicks on the first one. And up comes the failure mode data on the right side in pie chart format. You drill down on it to the failed component problem, and the cause code. Imagine the wealth of information at your fingertips. And now you can start making proper corrective actions. Okay. Well, I hope this is a good start for tomorrow. I'll continue the subject tomorrow. Yeah, and good luck on the SMRP test that you'll be taking for whomever's going to take that this evening. Thank you for your time. All right.
I think we have a few minutes for any questions.
Yes.
So the system we currently use is SAP.
Sure. SAP PM.
Yeah, exactly, SAP PM. And we were lucky enough to be able to enter all our failure codes, all of that stuff in there. So any type of emergency breakdown that we have where the line goes down, the tradespeople are able to put all that information in down to component level, which is really, really nice. The problem where we always fail at, though, and looking for suggestions maybe, is that we're not showing the benefit to the trades guys why we're doing this, and then it doesn't get done.
Thank you. I'm going to repeat a little bit of what he said. So he's got whatever software, doesn't matter. They've got failure codes in place. Maybe it's an equipment hierarchy with components at the lowest level, don't know. And they've trained the staff to put in the proper failure codes against the right asset component. But if you listen to the scuttlebutt from the trades, they're not all happy with middle level management on having to put this data in, and they may even be careless sometimes. And if the system lets them, they may even leave it blank. Who knows? But to answer the question, if I'm you sitting in that chair, or when you go back to the site next week, I would definitely show them the failure analytic. Now, you can have this software, you can have the failure codes nailed, but if you haven't taken that next step and designed the failure analytic, that could be the problem. So you want to be able to show them this is how the data would be used. The data is meant to help leadership, reliability leaders, whom could be anyone in the organization. make more informed decisions to remain competitive. Some companies are private here, and you don't know what could happen tomorrow. Another company can make the same product, produce power at a less cost, and put you out of business. So competition is important. And personally, the other angle I would answer is, as an employee, you want to create a knowledge base so you can manage by exception and make more informed decisions.
Would it also make sense to maybe have some of the employees participate in the failure analytic?
Yes. Oh, thank you.
So they understand why the data is important?
Yes. So when you buy the $1 million software package, this analytic will not be there. So I would get the reliability team, the reliability engineer, the maintenance manager, and whomever else believes that they have input, and get them in a room and design this thing. What should it look like? This is the end game.
Not only that, but also visibility. I think they need to know when this kind of analysis is done, all the maintenance team have visibility of what is happening. And I think that will create engagement and understanding what this is done.
Okay, what's your first name?
Carmen.
Gandhi?
Carmen.
Carmen. Okay, thank you. Yes, visibility. So data visibility, by having the analytic, you're able to show whomever wants to see that this is according to the data in the database, these are our bad actors. And if you have 3,500 assets, you can't manage them all, but we know which ones are the worst offenders. And we believe, as management, by focusing on the worst offenders, we will be doing the absolute best we can each day we come into work by going after those bad actors. Visibility. Yeah. Okay, great questions. All right, thank you. All right, well, we'll see you tomorrow. If you don't mind, I'm going to take your picture as the audience, so my boss will know that I really was here. Okay, good. Thanks. Very good. All right, well, we started yesterday, and I'm sure you maybe forgot a lot of that over dinner last night, so I'll just do a quick review. I was hoping that some of these points here carried over from yesterday, so we'll find out. Chronic failure analysis. Dr. Penrose is gone today, but he did talk about RCFA, right? And root cause failure analysis, I mean, why did the Titanic sink? I mean, that was a big cause-effect tree there. But hopefully you're not doing a root cause analysis every week or even not every month. That's for a very serious catastrophic event. But what you should be doing is chronic failure analysis. These are the guys that are lower profile perhaps, but they're recurring failures. And as a maintenance manager or a reliability engineer, you definitely want to focus on these things. And wouldn't it be great if you could run some type of magic command in your CMMS software that would group these and pull them out and identify a top 10 list, okay? That would be first step. And okay, now once you have your top 10 assets in place, maybe you pick the top one, wouldn't it then be great to be able to drill down on the failure mode? And we're going to I have several more slides that really does a good job of defining the failure mode. And when I talk to RCM professionals such as Nancy and many others, they always give you a hard look back before they answer the question, what is a failure mode? Because there can be slightly different interpretations based upon the person's background. Of course, there are standards, but even myself, I've twisted it a little bit to fit the objective I'm trying to achieve. Now, let me build on that point. So I'm just a little old CMMS guy, grew up in a cornfield 80 miles southwest of Chicago. And I'm going to step into Nancy's world here of reliability. I'm stepping in, putting my foot in the window there, and I'm bringing a different perspective. maybe that no one else has seen. And when I do that, provide that different perspective, all of a sudden, many ideas start popping into my head. Well, why is it we've got a room full of reliability experts and they've never thought of this before? Point in case, converting failure modes to failure codes, right? So from a CMMS perspective, if you want to extract reports, you have to be able to understand a little bit of SQL. Okay, now if someone records a brand new failure mode, let's say Nancy was at the site, your site, 6 months ago, performed an RCM analysis on 2 very high critical systems at your facility. And that data has all been recorded. But now Sean comes in this coming Monday, Tuesday, and he writes a brand new repair work order in this particular same system. And come to find out, this failure mode that he's identified was missed by the facilitator. That could happen, right, Nancy? Yes. And even people have said that no RCM analysis should be laminated and taken as gospel forevermore. Things change in a plant. And so it should be a living document. Those are important words. If I were giving a test at the end of the day, that would be one of the questions. You want to create a living document. It's not something that's static. Okay, so failure mode. So Sean identified a new failure mode. Wouldn't it be great if the moment he saves the work order, a little hand would jump out of the computer and slap you in the face and say, hey, that's not on the facilitator's list. You just added a failure mode that wasn't there. Okay, well that's a bit silly, but maybe the work order could be electronically routed to the reliability engineers. Let's see a show of hands of the reliability engineers. Yes, thank you. And so it's routed to you. Maybe the next morning you come in and you see this message, and then you make a decision. Is it a valid failure mode? And it might very well be. And should I add it to the official, the original list that was created? Okay, so that, in 5 minutes there, that is my first discovery as a CMMS guy, which is, why don't we put the failure mode on the work order screen? Okay, now there's a subset of that. The failure mode right now in some definitions is like a sentence. It's a bearing seized due to lack of lubrication. Well, for me to do this SQL validation, I need to create dissectable fields. I may be inventing that word, I don't know. But hopefully you know what that means. So I would need how many fields to dissect a failure mode? Anyone want to guess? 4 is a good guess. I'm trying to do it in 3, but that's close enough. So the first one is the failed component, and we'll discuss that. And then the second one is the component problem, and the third one is the cause. Now the cause code I've actually made a cause code tree because there's many levels of causes, and I'll show you how that can be selected. So again, when I make dissectable fields, and that is a perspective that I've suddenly become aware as to how I can benefit reliability data inside the CMMS. Okay, number 2 benefit that I observed once I stepped into this world of reliability was that it seemed like you could spend a lot of money for these software products, but none of them, absolutely none of them, have a decent failure analytic. Okay, but they give you the reporting tool, the engine, for you to write it, but you still have to know what to write. Related to that subject, and I may have said this yesterday, the implementation teams, 9 times out of 10, are run by the IT department, and they've got a schedule, they've got a budget, and they're loading data, they're configuring screens, and they're going to train staff, but they never talked to the reliability engineer. They didn't invite you to the meeting, Nancy. They didn't think you were important enough to contribute to the design of this system. Isn't that silly? And that's going on today. Now, not every site has a reliability engineer, but you don't really have to be a reliability engineer to contribute in this regard. You could be a business analyst, you could be a planner, scheduler. Yeah. There could be reliability leaders throughout the organization without the formal title. All right. Well, let's stop there. I'll get back to this slide. So know the difference between an asset and a component. Every site that has assets, I would hope that they would have a document somewhere in their business library that says this is the definition of an asset. This is what qualifies as an asset. I was working at a university facilities director level, and we had a workshop, a large meeting, larger than this even, and they had all of the middle level managers there. And I asked them to invite some of the trades because I wanted their input, and they showed up too. And so one of the questions I asked, well, you've got 700 buildings here on campus. What percentage, do you have all of the assets that need to be assets loaded into the software? And I'm expecting an answer like, 80%? And the craft guy who we invited was not shy about raising his hand and shouting out and saying, we're lucky if we have 50% of the assets. Oh, gosh. I couldn't believe it when I heard that, nor could the rest of the middle-level management. So this is like the iceberg slide that we saw from the pilot yesterday. And you might be amazed what the working level knows, and you need to be asking them for their feedback, for their input on a constant basis. So 50% of the assets are missing. How would that happen? Well, at a university, they're always building new buildings, and the deans are naming the new buildings after themselves, and millions of dollars are invested. And when the building's about to go operational, they provide a list of everything, assets, but it's probably in Word document, might be in Excel, but it's a bunch of loose papers, and it's not easily loadable, another word I'm inventing, into the CMMS. So moral of the story there is, shouldn't the contractor or the construction team start earlier on creating the precise template for rapid load of the assets into the system for when the moment arrives that they turn over those assets? Okay, that's that speech. Yes. Oh, please.
Okay. So we do a lot of assessment all over the world, maintenance organization, and I can tell you, not even 50% of the companies have a complete accurate data on the asset, which is really fundamental. I'd like to have a show of hands here about the people who think they have a complete inventory of their asset and accurate. Of your asset, of your mission critical asset, do you have a complete inventory of your mission critical asset and accurate? Who has that?
I think I bet I have about 90%. Because the ones that I don't have probably are the ones that, like the equipment that went away, like gone.
So,
And we had to take it out, but I mean, the stuff that's been there, it's been there.
so mission critical, it's all there. So good. And that's the point I want to make. That's fundamental to start with.
Thank you, Sean. This is foundation data, and if that foundation data is not in place, it's real hard then to even discuss advanced processes, which is what I'm talking about. So stepping back for a second, you can and will hear presentations on what CMMS software to choose, how to implement it, and turn on the basic features. I'm discussing advanced processes. So I'm jumping into topics that are near and dear to me, and the whole benefit of an advanced processes, and there's several of them, I'm going to try to cover all of them that I know, is that's where you receive the largest potential return on investment. Not for just making work orders. Yeah, you can have KPIs, but if you don't have the failure analytic, you're not really making decisions that will help you take corrective action and manage by exception. Manage by exception. All right, I keep getting off track. Failure mode is the language of RCM, and it's certainly a key part of the standard called SAE JA 1011, 1011, 12, and I have a slide on that. I have a soft copy of that standard, and I did a 2-word search on failure mode, and there's hits on every page. There must be 10 hits on every page. And as I said yesterday, you log on to the world's most powerful maintenance management software, go to their online help, do a 2-word search on failure mode, absolutely no hits. None. Zilch. Zip. Nada. Okay. Isn't that something? And so the software vendors frequently confuse not only themselves in the R&D department, wherever they sit, but the customers when they casually throw around these words, failure codes. Well, failure codes are not failure modes. There's a difference. All right. All righty. Failure mode has 3 pieces. This is my definition. Others can differ, and I will appreciate that. Failure mode is best captured outside of a failure code hierarchy. The software I use does have a failure code hierarchy, and so the theory is level 1 consists of the failure class, so HVAC or boilers or pumps or whatever. And then all of the subsequent levels are within that family tree. If you were to pursue that and you filled out the entire tree for all assets and asset classes at your site, you potentially could have a 4-level hierarchy that has over 100,000 boxes. This is silly. You know, the bottom level is called remedy, and you don't need to be replacing remedy, the same 8 values at the bottom of each of these trees. This is ridiculous. So in summary, it's my professional opinion that the failure code hierarchy design is flawed. And therefore, all you need is 3 brand new fields, and you can properly capture the failure mode, which is what we really want to do. Maintenance is performed at the component level. Okay, it's an obvious statement, right? But when you log on to the work order record, on whatever software you're using, you link it to the asset, maybe the location. There's no field for the component, unless you've built that into your hierarchy taxonomy. Okay, SAP, you know ISO 14224? Either do I. Okay, I hesitate to bring that up then. Well, somehow someone told you that you not only load the asset, but you load the components within it, within the tree.
The function, location, structure, then we go to the...
All right.
then we go on.
Have you been there at the site for a while?
Sorry?
Have you been at the site for a while?
27 years.
Okay, good. How long did it take them to build out that hierarchy?
So they didn't, Josh and I did. They came in with the software, gave us suggestions of what to put in,
Yeah.
how to do the PM module, and basically with Josh and I, with our knowledge, we went through the whole line. We would print all the CAD drawing of the line, we go to every piece of equipment, verify it's there, get it in the system, work from there. So we actually built the whole plan.
Okay, but you did this in a weekend or what?
No, absolutely not. Absolutely years. This is years. Yeah.
Okay. I was hoping they would say that. I'm being a bit negative here. I was hoping they would say the word years. All right. Now, this is a major design difference. You will be successful at how you've set it up and how you plan to use it. You're going to be good going forward. I'm just saying not every organization has the resources or the patience to build out all of the components below each asset for everything in the plant. And that's ISO 14224 is the standard that sort of promotes that. And so sometimes I'm nervous when I make this presentation because I am contrary to a standard. I'm proposing a design which is contrary to a standard. And I'll talk to Terrence about this, and he's okay. So if you can be successful at gathering analytical data for failure analysis purposes with the resources you have and however small or big your size your organization is, I'm saying go for it. So keep that in mind. I'm proposing a design that's a little bit different than how you've got it. I do not put the components in the equipment hierarchy. I put them in standalone field, and I'll show you more on that in a little bit. I'm not suggesting that you change. You stay the way you are. You be good. Okay, all right. Functional failure. Now, I did cover yesterday. I mean, if you have the ability, when you get back next week, talk to the CMMS guy, alrighty, and ask him if he can add a field to this work order screen, and that field would be a yes/no field. It'd be titled, was there a functional failure during this repair activity that preceded it, rather. And then it gets into the discussion, well, what defines a functional failure? And maybe they get that wording and store it in a long description on the asset record. Yeah, okay. But the point is, as I made yesterday, Nancy, to the audience, was it's difficult to extract using SQL the mean time between failure metric if you don't have that field. Now, you could go after downtime, but very few companies capture downtime. So I'm trying to provide a solution that's not as complicated as the root cause analysis, but will still give us very powerful data to do some very powerful things. Okay, all right. Nobody's shouting out at me yet, so let's continue. Establish clear roles, yep, and okay, and there we go. We're moving on now. So culture, whatever I try to do, I'll go back. Whether I'm implementing software or working with a project team to implement software, upgrade a version, or just perform site assessment to influence change, it always comes back to that word in the center, and that's where I stumble. It's the hardest thing, that culture. So I define culture as a willingness to change. It gets into change management. It gets into personalities. It gets into yeah, we'll leave it at that. So I do postings on LinkedIn every once in a while. I'm sharing knowledge for whatever reason. Where's Rob? Is Rob in here? Okay, not this moment, but anyways, he does a podcast, and Nancy does postings too. But I did this posting just last week, and I'm real proud of what I put in the post, right? So I'm happy. And then sometimes you get comments, and the first comment is, "Oh, looks good. Thanks for that, John. Nice entry." And the next one says, "Well, I didn't quite understand everything you said." Okay, that means my fault. I need to go back and revisit the wording, and sure enough, the wording needed to be clarified. I fixed it. Yep. But then the next comment says, "Yeah, your thoughts were valid, but quite frankly, at our plant, the culture is so bad, we can't even begin to think about these advanced ideas. So John, tell me how to fix the culture." I hate those questions. I hate those questions. That makes me, I mean, it's a great question, but now I've got to really step back, find a quiet moment in my office, sit down and think for about 15 minutes, how am I going to answer this guy? I haven't been to his site, don't really know anything else about him. I'll go look on his LinkedIn profile, see what industry he's in, he or she, and that's about where it ends. But then I tried to do my absolute best to answer, how would you address the culture? Now, It would be easy if it was just a matter of software. It would be easy if we all had someone like Nancy to help us to perform RCM analysis, but it's not that way. So I made a few notes, at least I thought I did somewhere. And it might be on my table there. Okay. Oh, I got it. Well, well, thank you, Nancy. This is it. This is it. Yeah, will it stay, you think? Okay, great. By the way, the magic word is configurability. Does anyone here know what Groucho Marx is? Ever heard of him? So he had this game show, we're talking like 50 years ago. And he had a little roll-down piece of paper and on a tie string, and the magic word is that. So he interviews people, and if they happen to say it, they win $64 or something. Right? I don't have $64, but this is the magic word, configurability. Yep. And I'll come back to that point. So we're talking about culture. How did I answer this guy? I don't exactly remember, but I made notes just this morning. Let's say you've attended this venue, you've got a lot of new ideas, you're going to go back to the office next week, and as it turns out, in your organization, you may be the only one in the building that understands anything about reliability. It could happen. Is anyone in that position where you may be the only one? Okay, okay.
We have the opposite problem where everybody understands it.
Okay. I'm glad you came back.
They know way more than you do, just ask them.
Okay. You weren't here yesterday, but I'm glad you came back. All right. Yeah, John. All right. Yeah, so the advice I would give you is, even though you're by yourself potentially, take a stand. I mean, what's the worst that can happen? Well, they might fire you. I don't know. Take a stand on reliability, and so you might create a large poster or even a collage, put this on your office wall, and it would show start to finish a design that I call future perfect. What are all the elements of an asset management system? What should be in it? What type of failure analytic? What type of data would be capturing? What kind of roles should you have that you don't currently have to ensure accurate data? Yeah. Okay. And so you got the collage now. Let's pretend you've got it. Very colorful, very artful. You did a great job. Now, it's early in the morning on a Monday morning, and you hear someone walking down the hall, and by God, it's the CEO. All right. Stick your foot out there and trip him. No, don't do that. But say, hey, Bill, can I talk to you for a moment? And I'll get a cup of coffee going. He comes in your office, and you just start small talk, whatnot. And in a moment, he's going to turn around and see that collage on the wall. Now, for me, I got a lot of ideas in my head, and they're going every which direction. It helps me stay organized. So if I had this collage, if I was you, it would help me present my key points. This guy's busy. He's got to come and go. Key points in short order and help him understand where he could be. You're presenting ideas on how to improve operational efficiency at your plant, how to reduce costs in maintenance. He might be interested, he or she, and this is your moment. So be prepared for the moment. That's the message takeaway. Let's say you had a process in place and it requires, we added these new fields to the screen, but you need people in certain roles to enter the data. When the job's done, I need this functional failure to be marked. I need to now capture the failed component. What if you have a trade, Doug, what if you have a tradesperson, you know, he's a bit ornery like me, and I don't have time to update that field. I'll give you actual man hours, I'll say that job's done, but I'm not keen about entering this data. You sense that. Maybe he doesn't tell you outright. There's a little bit of fear going on, but he doesn't he's not necessarily on board, right? So how do you handle that? It could be various ways. Maybe this guy is a bit savvy. He points back to the job specification, and the job spec doesn't say anything about this. I don't know. Well, you can't fix things overnight, and you don't want to fire everybody. I mean, that's not good. But you might go to the HR department, not to report on this guy, no, but to sit down with the HR manager and have a discussion. That's all right. On, we need a very clear job specification to help us capture accurate data in support of advancing reliability for our thousands of assets. Now, I think the HR department could help us here. Maybe, I'm speaking for you now, maybe we need to provide a more clear, precise job definition. Not just a job specification, but a job definition. Let's be real precise here. Okay. And hopefully the HR manager would agree, and maybe that person has to get approval from the plant manager or something, I don't know. But if they agree, then you could put a process in place whereby any new hires would be totally informed that these are the requirements, no wiggle room. You've done this?
We did that.
Oh, that's amazing. Where'd you get that idea?
Yeah, we were able to do that. And then we also, part of that is there's a box in SAP you check for breakdown emergency work order that
Yeah.
requires those fields to be filled in. So our tradespeople do that every day.
You know what? Like I said, I use one particular product. I don't really know the others, but I'm always looking. If someone does a post and shows a screenshot from another software product, I think I got this idea for functional failure from SAP. I think I did. I remember seeing this field. Yeah, I remember seeing it on the work order entry screen, or notification, whatever you call it.
And we have SAP too, and it actually tracks the time. If you do a breakdown notification and it's a breakdown check mark, it actually tracks that particular
Oh, yeah.
figure and work order and the time that you spent on that.
We need to switch software. Good stuff. Thanks for sharing that. Yeah, so, yeah. Configurability. What if you have what if you're a very much smaller company? You don't have 3,500 assets, you only have 35 assets. Yeah? So you can't afford the SAP, you can't even afford the product I use, and you need to search for a good product, but it's at the lower end. The thing you want to focus on now is, can that product be configured? Yeah. Maybe you don't have the ability to configure it on site because it's a pretty much closed box, but you could make a phone call to the vendor and they might do it for a price. If it's a reasonable price. We're just talking about adding one field here. Yeah. And that's, okay, option 2. What if the responses to all of these questions are no, 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 and no? Okay. Well, then, this gentleman here took matters into his own hands. I'm talking that John Laskoff from the nuclear side, and he got a hold of some other software. So screw the CMMS product. Can I say that? Okay. I've got a job to do, and I need to capture data, and by gosh, by golly, I'm going to maybe store it in this other system so I can produce what I need to produce and add value to the company, whether or not leadership knows it or not. And that's what he did. Okay, now he was actually downloading data from CMMS, but I'm suggesting that you maybe even add a few new fields, such as the functional failure, and start capturing that somehow in your process. Okay. Culture. HR department. So I was at a venue with Terrence O'Hanlon, Reliability Web, and that was the first time I actually heard him emphasize HR department. He actually shouted it out. I about fell out of my chair. He said, HR department, don't forget them. Use them to your advantage. Change won't happen overnight, but get them on board. All right. All right. Anyone know the name Graham Fogel from South Africa? Okay, he's definitely in our business, implements ISO 55000 asset management strategies, and has great graphics. And I think a recent editorial he did in Uptime magazine had this type of graphic, and I'm not shy about stealing graphics. I tweak them a bit, but this is basically his. So we've got 3 states in his mind: a reactive state, a line state, and then future perfect state. So the reactive state morale is low in the workforce. Unclear how to reduce reactive maintenance. Well, okay, I've got a slide on this coming up, but anyone brave enough to raise their hand and answer the question right now, what is one thing you could do to reduce reactive maintenance? This is a tough question, but it's something you want to be prepared for the moment when the CEO comes in your office. I'll get to that slide. Okay. The software itself lacks decision-making capability. It doesn't have the analytic, inadequate work scheduling. Jean, you heard that? So with or without the software, they don't have any processes in place for good planning and scheduling. Production downtime is excessive, and customers are impacted. Okay. Align state. The CMMS is configured to extract knowledge. There's a theory. Advanced processes are in place. Analytical reports are created. Clear roles and processes exist, and you have a closed loop feedback, which continually improves the RCM analysis, the PM strategies, job safety, etc. KPIs are in place. Reliability team. A lot of companies don't have a reliability team, but if you have a failure analytic, I mean, who are you going to give it to? You're going to give it to the planners? It helps. You could give it, if you have a reliability engineer, you could give it to him by himself, but there's better analysis as a group. So if I were picking a reliability team, I would have reliability engineer, I'd have a business analyst there maybe. I have the planner schedulers, or just their lead. HSE guy. HSE. Everyone have an HSE guy? Okay. Operations side, and maybe the maintenance manager. Okay. Who else would you have? Reliability team. You have one, I'm sure.
Oh, yeah. Well, you know, I mean, if you're quite, our reliability team is it's a function of the SMUs, but mostly component SMUs.
Okay.
Some of your situations.
So in a nuclear plant, they have system or subject matter experts, and SMEs is the acronym, and those guys are very knowledgeable, heavy operational background as well as a little bit of engineering and maintenance knowledge too. Okay. All right, let's move on. So a future perfect design. Reliability leaders are throughout the organization. They may even have certifications to that regard. Could be SMRP or CMRP or CRL or whatever, CRE. And ongoing benchmarking. We talked about that yesterday. Culture of reliability throughout. Accountability is enforced. Your executive sponsor is on board. And you have a living program. Okay. So who owns reliability? Well, I can give you the answer right now. It's everyone. All right. And so management, engineering, purchasing, storeroom, planner, schedulers, operators, maintenance staff, reliability action team, core team. Fine. Best-in-class organizations have a culture rooted in reliability. So these reliability leaders, there's not necessarily a title for a reliability leader, but generically speaking, maybe they have a CRL certification, and they could be anywhere in the org, and they frequently take a stand for reliability. So they have great influence and a sense of purpose. They exude the 4 fundamentals of reliability leadership, which involves integrity, authenticity, be who you say you are, responsibility, and aim, a sense of purpose. Those are not my words, those are Terry's. Okay. Visionaries help communicate vision, support the goals of the organization, facilitate change management, identify roadblocks, as well as provide solutions, opportunities for improvement. That's reliability leader. And I put this bottom one in, which is a key point. You want to be able to position to promote database decisions, leveraging the data in the CMMS. Many times, an organization that doesn't have their act together, if the plant manager talks to the reliability engineer, he says, well, why did we just go down? What was the main problem? Why did this asset fail? And the person answering is answering based upon tribal knowledge. Maybe you go to the maintenance supervisor, foreman, and you ask them, what's your opinion here? But really, it's tribal knowledge. If you had one table of supervisors, you could ask them all independently, what is the worst asset, performance-wise, at the facility? If you ask them independently, I'll bet you money you'll get different answers. But let's say they all gave the same answer just by chance. My next question back to them is, well, can you run a report right now from the CMMS that will give that exact same answer? And that's where we want to end up. Okay. Okay, org chart. So coming back to the culture issue, the traditional org chart is sometimes not that helpful for us in advancing reliability, advancing accuracy of the data in the system, leveraging the tool to make better decisions. The traditional org chart is not that helpful. Well, maybe we need to change it. I mean, you can go on the internet and you can see all these articles, professionals throughout the world saying, well, your CMMS data sucks. You know, I sort of get upset about that, but they're right. So we need to figure out a way to fix this, whether it's the missing foundation data or the transactional data that we want to capture at job completion. So we might add some, we need an executive sponsor to begin with who has some understanding of asset management. So at the nuclear plant, John, do you have that? I'm sure you do. An executive sponsor, when you reach a roadblock and you need to reach out for help, you have someone you can go to?
Sure.
Yeah. Okay. Some companies now, in the last 10 years, companies have been introducing the job title reliability engineer. I mean, before that, it didn't really exist. There's also a title called asset manager. Does anyone here have an asset manager? Could go by different names. Within the asset manager, in this drawing of mine, I've got a core team who runs the asset management software and also a business analyst. I really love that business analyst role. The business analyst would regularly visit the working level. He's the go-between. He reports to the core team maybe, or the IT department, and the working level would say, well, I need training. The software is too hard to use. The click count is too heavy. I need a report. I've always wanted one. I told Jim Bob I needed the report, but here we are 6 months later, I still don't have it. So on that subject, a conversation could be that short from the working level to the whomever he's talking to. I need a report. Title is this, but there's no design spec. Okay, so give IT some credit here. They really need a design spec if they want to write a report. Who would write that design spec? The business analyst. So you make it easy on the working level to communicate a need, but the business analyst goes back to the office and draws up what it looks like, gets approval from the working level guy, and then he takes it either to the core team or the IT department. Business analyst, that's one role of a business analyst. Number two, some organizations, I've been to one, I walk in the door, first day of a 3-month assignment, and within the first 5 minutes, I'm in the trades shop, and within the first 5 minutes, one guy looks me dead in the eye. He knows who I am. He knows the software I'm supporting. He says, Maximo sucks. Okay. There's nothing I can say in response at that point because it's too early. I have to just let it roll, you know. And but this, if the culture within the entire shop is what I call reached a tipping point, whereby they've gone so far south, you will not be able to recover at this point. This is a sad story. And so no matter what I do in that time there, the odds are very minimal that I will successfully get them off that tipping point. Just the way it is. And for leadership to get them off that tipping point, they will have to do something dramatic that will shake the earth they stand on, which might be, short of firing people, they may switch out the Maximo software altogether and bring in SAP or Oracle or something else. That's shaking up the routine, making a major impact. Now, that's not necessarily, it wasn't the fault of the software necessarily, but it's just that's all leadership knows to do. And that's what they did. Okay.
Can I make that, John, can I make this?
Yeah.
On the asset management part, I'm assuming that, you know, they can part of your long-range plan team, that's how it works in your brain, right? Okay, so, one of the things that I've seen in our industry is, as we strive to be more efficient, effective in our maintenance strategies, and moving more to using predictive sciences to say, hey, we still got life in these assets. What we're finding is we're starting to clash with our asset management team, because the asset management team goes out and they go to the owner groups that may own the nuclear plant, like there's 7 owners of the Palo Verde nuclear generating station, and they go, hey, we're going to change out this $2 million asset in 5 years. And then they pull together the capital money, they put together the plan to change it, they do all this stuff to get it ready to change out. And then you come along, you know, a year and a half before they're ready to do it, and you go, I'm going to extend it. And it causes all kinds of issues in the business world with what they're trying to do. And all I can say is if you start getting into those problems, you're doing your job. You know, because there's going to be smarter people that are going to have to figure out where they really want to go down the capital lane and spend the money at that moment or not.
Thanks for that. Yeah. It's not easy to change an org chart, but again, if the data is inaccurate in your system, you're in a bad place because you cannot produce any analytical reports. And you can do KPIs all day long, but it definitely will struggle to produce meaningful, accurate reports that anyone would use. And now, if you can't do that, you're back to tribal knowledge. $1 million later. Okay. This is more on the same subject. And this says what a core team does. Not everyone has a core team, but I definitely recommend you have one. The quick story here is, if your site only has one person running the CMMS, you are at risk. Just like an asset can be at risk, the system is at risk if you only have one person running it. And this is why. So that person, let's pretend his first name is Larry. I'm Larry, right? I get a phone call from Sean saying, hey, I want a field added or hidden. I want to hide a field on the screen because I don't use it. And it clutters up the screen, quite frankly. Okay, so I try to call around to other departments and make sure they don't have a problem with that. But I forget to call Doug. My fault, maybe. I forgot to call Doug. No, Doug's pissed because I just hit a field that he was planning to use going forward. There wasn't any data in it right now, but he was planning to use it. All right, so the point is, with a single point of contact, this is similar to asset world, single point of contact for running the system, you will get in trouble. If you had a formal core team with a prioritized punch list, that's the best way to run the system. One of my faults is that I make too many slides. And secondly, the slides I have are very busy. and I know you can't read everything in the back of the room for sure. The good news is Jordan, the conference organizer, is providing all of these PowerPoints, software copy, to the attendees. Jordan, will it be a real PowerPoint, or are you going to do PDF? PDF. PDF. Okay, fine. Yeah, all right. If anyone would like to, if you see something you like here and you want to actually get the PowerPoint, mine are very much animated. Simply contact myself or Brian. He's not in the room right now, but afterwards, and we can organize that. This is my favorite slide, and the reason is it's number one, it's animated, but also it's going to show you a 5-step plan. In 5 steps, you can implement reliability for your asset management system. RCM, I call it, for our asset management. So let's see how this plays out. Step 1, well, we need that asset registry that we talked about. That needs to be in place, and there's fields on the asset that should be filled in. You want to know what the functions are defined to make that asset functional, or functional failures, that is. You might have a service level agreement on it. You might have a criticality, a business risk exposure numeric grade, and we'll get to that. You could have someone reporting monthly asset conditions values on this thing. Now, if anyone is doing that right now, I would be pleasantly surprised. Is anyone in the room currently capturing asset condition on a monthly basis for their major assets? No. Now, I know the sensor data is wonderful, and you've got all these sensor points on the asset, but that it's not normally possible to convert the sensor points into one high-level condition grade, and so a human is normally involved. And the way I would do that is if you have a monthly PM taking place, have the planner add a job step at the end that says, before you leave, give me an as-left asset condition, and the grade span is 1 through 5, and this is the descriptive for each. Yes, it is subjective, but as a maintenance manager or plant manager or reliability engineer, imagine the wealth of knowledge across thousands of assets if you suddenly had that additional parameter to start trending with. Imagine the value. Okay, asset condition. Yep. So that's our step 1, RCM for asset management. Reliability strategy creation. Well, this is what Nancy does, and she's going to explain that in detail, I think. And there's a process that you go through to identify failure modes. Now, there's RCM analysis, and there's also PM optimization, and then for some assets that are lower in criticality, you could simply go after the OEM guidelines. But I was at a presentation, the Reliability Web, a few years ago, and Nicholas Desplain, do you know that name? No? Okay, fine. So he's from a manufacturer, it might be the food industry, and what he does as a maintenance manager, he's now a director, he goes and talks to each of the seasoned supervisors, foremen in maintenance, maybe some operations staff, gets them around a table and says, for this asset, what are the things we need to be addressing failure mode wise? And he doesn't perform a formal RCM analysis, but that information right there, he starts with that, and then they continually refine it, and they've been successful. Okay. So once you get the RCM analysis done, you need to convert it and put it into the PM application as strategies. Some can be calendar-based, some can be usage-based. So a strategy can say perform servicing, or it might say conduct a route. So Chuck has a lot of routes going on for condition-based technologies. By the way, you will not hear me use the word predictive. That was an old word that was used incorrectly, and I do my best to always say condition-based technologies now going forward. It's not catching on yet, because CBT, nobody knows what that is, CBT. All right. Yep, PM, job plan strategy. And now we've got the planning and scheduling side. We've got work order prioritization, backlog management. Anyone in here have 1,000 work orders in their backlog? I'm looking at Mr. Nuclear. No? Yes? Okay, they're being honest. It depends how you define and measure backlog, of course. We could get into that conversation, but some people have 500 or 700. The next concern related to backlog management is the accuracy level. So here's something I call an error check. I can run an SQL statement. I can arrive at your site on Monday and write a SQL statement against your backlog. I will find work orders that have been closed out with no hours on them. I'm sorry. They're doing it right now as we sit here. Okay. Yeah. I could find a work order that's still in open status. We call it in prog. Do you have a different synonym? In prog. But the last reported actual man hour on this was 4 months ago. Could that happen? Yeah. I'll find that. And unless you run, the CMMS administrator, unless he's been told to run these types of proactive error checks, no one else is going to do it. All right, you guys can go home early today. This is good. You're doing good. And you've been...
I have a question.
Yeah.
So from your perspective, how do you define predictive versus condition-based?
Predictive is the newer tech discussions, the newer dialogue, the newer conversations with AI and machine learning and the sensors. I mean, Chuck can answer this. The technology is now at a point where it can predict problems for you using sensors and a machine pattern learning, perhaps.
Okay.
Stuff that's way above my head.
Okay.
So it's truly predictive.
Okay.
Was that, are you with the same thoughts?
I'm curious, so that's the difference. So in your mind, condition-based is more like stuff that...
Yeah, so condition-based technology, you go out and perform oil analysis or vibration and ultrasound, infrared, and you discover a potential a defect, a potential failure. It's not functional failure yet, but you're able to read it now using the advanced technology such as vibration, whereas the human senses would not see it. It's, that's later on the curve, right? So, yeah, and then you should make a follow-on work order with a work type of condition-based maintenance. Different organizations do this differently. They call it different things, but you want to uniquely label it because that's a KPI in itself, tracking the amount of discovery follow-on work orders from a well-qualified CBT inspector. And you want to know where that puppy resides in the backlog. Now, I would suggest here, since we're on the subject, the CBT inspector should put a deadline date on that work order. Don't leave it up to the schedulers to schedule this when they think they can slip it in. We have different concerns here now. Well, you do handle this, but I'm pointing at Sim. But definitely put a date. The onus is on that guy to put the date on the work order. Maybe it's a brand new field so it doesn't get lost in the translation. So it sticks out. And then the scheduling people can manage accordingly. Yeah, they need to know the deadline date. You can do it before, but certainly not after that point. Okay. Well, we're on step 4, so work order failure mode capture. Now on the front end of the process, a work order or notification has just come in, and you may not know the failed component at that point. You may not. But when the work order, the job is done, absolutely the craft guy knows what component he worked on, no doubt about it. 100% of the time, he should be able to fill that in. I mean, if he can't, I mean, what the heck did he do? All right. All right. Now, will the tech be able to fill in the problem of the component? He may or may not. Depends. You know? I would say 50% of the time he should be able to take a stab at it. And maybe your procedure said, let him go ahead and put it in, but you're going to have a supervisor review it or something. Or maybe, yeah. And then on the cause code, that becomes a lot harder. If it's an easy cause code, such as wear and tear or aging, so wear and tear are the tires in your car. Aging is the rubber tubes, I call them tubes, on your car engine body area. They just age over time. All right, but if it's not that, and that's only like 12% of the time, then we're talking human factors. We'll get into that. Winston LeDay did a study many years ago and said 84% of all equipment failures are due to stinking humans. That's us. All right. All right. So it's not just the maintenance guy. It's the operator who operated the equipment outside a threshold. It's the warehouse guy who stored that bearing in a dusty area, uncontrolled humidity environment perhaps, heavy equipment going by down the aisle causing false Brinelling, whatever. Yeah, it could be the shipper who shipped the pump and motor and bearings on a flatbed, but it got a lot of bumps along the way. Could be the manufacturer who put a hidden failure in place, a design flaw, call it whatever you want. So it could start there, and those are all humans. It could be the buyer, the stinking buyers, that bought equipment that really wasn't up to spec. Or, yeah, it didn't have, it may have been up to spec, but its reliability standards were not where you needed them. Okay.
Hey, John,
Yes.
do you believe it?
Sorry?
Do you believe it?
The 84% number? Okay, I'm going to answer that. When you qualify it in the way I just did, I do believe it. So you give me a different opinion, because I want to learn.
I think that's exaggerated.
Okay.
The data that we've been looking at over the years, it's just not interesting. I think we magnify human error. When I look at our rework rate, at our plant is like 0.4%. That's how many maintenance-induced errors we cause in the year. I mean, it's not like what people think. What you notice is the bad one that shuts you down, you're sitting there brain, you know. But most of my equipment is wearing out.
Okay.
Are we sure that it's really human error, or is that we don't have the right process in place to make them take the right decision?
Good, Carmen, thanks. Yeah, so the process, I want to believe what you're saying, but I'm trying
Maybe
to,
talking apples and oranges a little bit too.
I'm trying to get there. Now, the process procedure was written by a human. If you think about it, it always comes back to a human. And if the procedure is not followed by the operator or the maintenance guy, well, that's the human. You know, in the industry we're in, the people are hesitant to get into the cause code. It could be on the screen, but they're not going to fill it in. Why don't they want to do that? It's just natural human tendency to not, well, hang on, no, to not get too personal with your peers, you know, because that could go bad in the workplace. You work with these guys every day. Sometimes maintenance will have a go at operations. They're glad to do that. Operator fault, fine. Okay, so what are your final thoughts on this?
Well, I can tell you in the reliability science methodology that we invented through Electric Power Research Institute, maintenance-induced failures and manufacturing-induced defects, if you look at them as a total percent of the total degradation that can happen on a piece of equipment, it's pretty low. Depending on the component type, it's 4%, 3%, 8%. And there's a lot of data backing that up. So,
Okay. Yep, I always appreciative of different opinions, and I respect your opinion on this and your beliefs. So, all right. So we're going through the 5 steps here, RCM for asset management. I'm going to show you shortly a very advanced way to apply risk-based prioritization of work orders. Very advanced method using a matrix that automatically ranks the entire backlog every night at midnight. Okay? Safety is important. You want to make sure that that's in place. It's a lot more than just the software. There's process procedure there, and people die when those steps are not followed. Okay, so now this number 5 is really the most important part of the entire presentation. It's what enables continuous refinement, continuous improvement of the maintenance strategies that you have, and you're doing it through 4 methods. The root cause analysis from Dr. Penrose. Number 2 is work order feedback. Do you have at your site, the SAP people here, do you have a formal work order feedback process in place? Wow.
For process safety management, for sure.
Yeah.
We've got job plans that are right with the work order that are downloaded. So we keep them on a centralized site, so we have control of it for that purpose. The planners will download all the paperwork given to them. At the very end, after they signed every step with pictures, the whole 9 yards, at the very end, it's comment section. What kind of feedback is it? So that's how we close the loop, is the tradespeople will fill that out. Josh or I will go out and sit with them and talk about it, and then we make the corrective work orders.
Great. But you said the word comment section, so free text narrative, yeah? Better than nothing.
Correct.
All right. Now, what I've done is taken it one step further is I have check boxes, yes, no. Do we have a maintainability issue? If so, give me the text below it. Do we have a design flaw? If so, give me the text below it. Energy efficiency issue? So, yeah. Okay, work order feedback, and we have a slide on that. Hopefully I have time to show. Chronic failure analysis, that's my favorite subject, if you haven't noticed by now. And defect elimination. Let's move on. That continuous loop will make you world class. If you're able to implement all 5 steps here, I guarantee all the money in Brian's wallet right here, right now, that you will become world class. Okay. Step 1, asset registry. On your asset record, at the bottom of that field screen, you could probably close your eyes and visualize that screen right now. These guys are good. All right. I dream about this at night. I don't know about you, but okay, all right, no, up there. All right. So at the bottom of the screen, the CIM team table, at the bottom of the asset screen, what are some of the fields down there? Yeah, main application.
Oh, shoot, I have, of the asset application. Oh, nice. Yeah, I can open it, I'll tell you right now.
That's cheating, but go ahead.
3 seconds, I'll be right back.
And could you come to the microphone when you have the answer?
Okay, we'll do.
Okay. Looking to see if I have the answer up there, and I don't.
Okay, at the very bottom left,
Yeah,
the downtime information,
yeah,
and next to it, the who last modified
Yes.
the asset record
Yes.
information.
yes,
I can go
above it,
above it. The purchase information about that asset,
yes, and
and next to it, the cost information.
give me the full label.
Of the cost information,
Yeah,
okay, total cost year to date.
Okay.
Can't read that.
right.
Budgeted.
Okay, replacement cost, is it on there?
Yes, it is.
Okay, fine, I'm good. No one fills that field in.
No.
We talked about KPIs in the earlier days. This is my personal opinion. The most powerful metric you can use as a reliability engineer or maintenance manager or whomever is the following metric. If you're taking notes, this would be the time. Average annual maintenance cost divided by replacement cost. That metric will normalize thousands of assets and float the bad actors to the top of the list, no matter how big or how small the asset is. Yep. Average annual maintenance cost divided by replacement cost. Now, here's a trick. Yes, sir?
How much you finish?
So one way to quickly fill in that replacement cost is to go after your assets by equipment classification, and you can globally edit these values. You know what equipment is $100,000 versus $10,000, and then that's a crude way, I know, but then you come in after the fact and micromanage, well, okay, this is a unique manufacturer and it's at less cost or more cost. But that would, in one day's time, you could populate 30,000 assets in that manner. Okay, well, John.
So, this was a learning for me, but at our plant, excuse me, I got to.
Yep.
At our plant, we had, we capture the cost, our warehouse charges when we pull our parts out of the warehouse, and of course, we have a price for the main component in there too. So if we pull out and do a replacement, we get that cost, and we also get that cost if we have a refurbishment. We were really having trouble getting the numbers to jive. We were pulling out all our price per units from our warehouse supply chain system. And here's what I came to find out. What happens is, so if let's say I send a motor off to a vendor to be refurbed and completely fixed and made like new, he puts it back into the warehouse. And what we do is we put in a charge to cover it for insurance. That's really the unit charge that is charged to it in the warehouse. It's an insurance coverage charge. The motor in the rebuild may have cost me $100,000, but it's in the computer system as $150,000 because I have to maintain my insurance coverage. So we have a disconnect between what we pay on our purchase orders and what our parts costs are in the warehouse. And us maintenance guys don't know that. We didn't understand that. And so when you start trying to put all this together, it puts a lot of inaccuracies into your system. So you're sitting there going, hey, I can't afford to do this. And the guys are going, we're not paying that much for that. What do you mean we're not paying that much? I signed the POs. I'm not paying that much for that. So you got to look for the disconnects. That's the point. It's not as simple as it sounds.
I agree. Yep. This is not an exact science. It's sort of like planning and scheduling. It's not an exact science, but I'm trying to get close. I'm trying to identify the bad actors from the good actors. I'm pointing at Doug. Doug's a good actor. And so that's all I'm trying to do. There are other metrics. A very crude metric is which asset last month or last year had the most functional failures. It would work, but that's crude. What asset had the most operational downtime? Well, that would be good, but most sites aren't even capturing downtime. What asset has a poor trending asset condition? That would be good, but you're not capturing that. What asset is just generally old? That would be crude, because just because the asset's old doesn't mean it's still not in good standard, performance-wise. Okay. All right, so let's move on. Capture, find, criticality assessment. So there are people in the profession that's all they do is perform an asset risk-based criticality assessment. And you may be able to do that, right, Nancy? Or no? Do you run those workshops or no?
Well, within Reliability Center Maintenance, we assess
of each failure mode.
Yes, yeah,
Yep.
RPN. But that's a different concept, really, isn't it?
Yeah, you're talking more high level, is that
Yeah,
right?
yeah, yeah.
Mhm.
Okay. All right. Thank you.
So you're talking like equipment classification? Is that what you're talking for risk? Are you talking?
Well, here's the screen.
Okay, all right.
All right, so configurability. This does not exist out of the box in the software I use. But if you have the wherewithal, if you have the knowledge and the vision, and you can walk up to the CMMS guy, and we'll call him Larry. Larry, can you configure the screen to look like this picture? He's going to say yes or no. If he says, could be political reasons, there could be his skill sets, doesn't know how to do it, or maybe you need to bring in the software vendor to do it, and the plant manager says that's too much money. There could be several roadblocks here, but anyways, let me explain this. So it's okay to just simply put a criticality value on an asset. That would sort of get you going. But it's more important to understand that asset and the way it sits operationally to assess the risk of it. So we had these planes go down here recently around the world, and the widget that's sticking off the bottom of where the pilots sit that had a name, and there's a sensor there, and something was wrong with that, as well as the software. But that should have had, if it's a single point failure, it should have had a high value here. Now, so business risk exposure. So on the asset application, you could add a new tab. Yep, they know how to do that. And then you set up these fields, and they have drop-down lists, and then there's formulas. Our software has formulas nowadays that you can apply. And so you answer these as a team. You're sitting in a room with operational guy, a maintenance guy, reliability engineer guy, safety guy.
Supply chain guy.
Thank you, Carmen. And you're getting all the experts, and they're going to be there all day, so it's not going to be fun. Actually, it's going to be all week. You're going to need to bring in pizza. All right. So you're going through the list, and you're answering these questions. Is there a safety impact, 1 through whatever? And environmental impact, process impact if it fails. Is this a single point of failure situation? Okay. And then you can pull data from the system as to the annual PM cost. You can pull that, and it will tell you. So you would come to the meeting with that stuff already calculated, ready to go. Yeah. Annual CM cost, repair cost, spares, longest lead time, that you would have that knowledge ready. And so this all comes together, and it gives you a final number, what I call BRE, business risk exposure. And this is a very powerful way in a numerical form to grade and compare all assets in the system. Okay. So now, coming back to the metric I was talking a moment ago, what if you had that value applied to every asset? What if you had the asset condition information coming into your asset registry? Multiply the BRE number times the asset condition number, and maybe that would give you a top 10 list. Has anyone ever done that? You guys again?
We just didn't do the money part, but we did the rest of it for all of our pieces of it.
Okay. I like these guys.
So that's in SAP, it's an ABC classification.
Yeah.
And then that's how we run our reports when we download to know what to send our loss teams.
All right. Okay, I'm moving on. I'm trying to give you my best knowledge here. I'm not doing real well with these guys, but yes, ma'am.
Are you recommending to do the asset criticality for at the first year asset level or going to components? And just to give you an example, we were talking about a packaging line. So packaging line have multiple components. Do you consider to do the criticality assessment at the overall, at the first tier instead of tier 2 or tier 3?
Okay, tiers. You could start at the manufacturing line level, which line is more important than the others, or maybe industry-wise, they may say certain systems are more important than others. Then that's your starting point. So Safety systems within a nuclear plant are very important. So when Nancy shows up, that may be the first system they start looking at and the assets below that. Did that answer the question? No.
No, my question is, for example, you have a packaging line. This is my system.
Yeah.
I consider that a complete
Good.
system. So,
Yeah.
and as a system, I have like a cartoner, different elements. Do you consider to do it as an overall system first, and then go through each one maybe in future? What is your approach to that?
You start at the system level, and that first week is on that one system, and then I'm going to go into the assets in the first day of that first week.
So to answer your question, we have a packaging line as well. We do it at the system level. That's how we've defined our asset criticality evaluation. But in the past, I used to work in a nuclear power plant, and we would do it at the component level too. And so that would be my recommendation, is once you get to that component level, because you may have some redundancy in there, and so some of your assets on there may be more or less critical.
Yeah, we could be stumbling over words, equipment, and components, and I'm trying not to say component yet because I'm coming to that. I'm going to move on. Do we have any people who work in operations in here, or previous career, previous life? No one in operations? Okay, yes, thank you. Currently? Okay, in the past. So you could walk into the office of the operations manager, and he's got a huge whiteboard in there. Yeah? In the upper left-hand corner, what's in that upper left-hand corner? What'd you have up there? Tell us. You can tell us. You had a list of bad actors. These stinking assets are causing me a problem. And I want to write them on the whiteboard so I don't forget. And when a conversation comes up involving that asset, I want that to keep that fresh in my mind, because I have things to say about those assets. Maybe it's design related. Maybe it's the way maintenance is maintaining them. Maybe operational procedures. Something's wrong with it. Okay? And so this is a way to track at-risk assets. Maybe it's a watch list, you call it, or at-risk assets. Find a way to make the software work for you. I mean, I appreciate you got it on a whiteboard, but who am I? I am the CMMS guy. So therefore, I'm going to find a way to configure your wonderful information and put it into my database. And almost every answer I have is going to be just that. If I hear that John over here at the nuclear plant is storing information outside of my CMMS, we're going to have a conversation, if it's asset related. Okay. So anyway, this is an at-risk chart matrix, and it's listing not every asset, but maybe 20 particular assets that operationally I've picked out. And I've got some color coding going on, and I'm saying at the next major shutdown, we need to do something. Or it's a specific shutdown in the future. Yeah? I can't read everything here. Repair at next opportunity. Repair as soon as possible. Just keep it on the watch list. Okay, so that type of thing can be set up in the CMMS if you so desire. Start thinking outside the box. That's all I'm saying. Not much to it, really. So BRE, business risk exposure. Nancy, you can disagree now. So you can't afford necessarily to perform RCM analysis on every asset in the plant.
I wholeheartedly agree.
Okay. And so by using the BRE breakdown, can I say BRE now? You quantify all of your assets into groups. So the top 10 to 20%, maybe that's where you perform RCM analysis. And then let's jump to the bottom group. In the bottom group, you might just simply go with OEM recommendations or ask for tribal knowledge input. That's fine. It's the bottom group. But the middle group, there's something called PM optimization. I don't know a lot about it, but I'll bet you could talk to it. And I'll leave it at that. And so that's how some companies approach this. Okay, I'm going to go forward. Now, back to our two worlds. Here I am. I'm just a CMMS guy from a cornfield in Illinois. I step into the reliability world. I'm looking around, and I see something that these guys have never said, discovered, realized that they could do. As good as Nancy's data is, it's in software outside of my CMMS. What am I going to do? Who would hazard a guess? I'll bet you can guess. I'm going to take that information and put it into a brand new application in my software. She can still do it inside whatever product she has, but when she's done, I'm going to upload it, and there's data load features. She could have 70 fields, I don't care. I can store all 70 fields on this screen in the application. I'll show the ones that are important. So there it is. There's the screen. So I've got the asset, location, system code, whatever. I've got to read it. I've got, okay. We've got a blower here and a silo and piping, and then there's functions and there's consequences. And if I click on one of these assets within the system, I can then start seeing the failure modes that she documented. Motor bearing seized due to lack of lube. And that's just showing one failure mode, but there could be infinite number. And I could see all of that on the screen. And below here in the red, I can have the suggested maintenance strategy. I've now put this inside Maximo. What's the advantage of doing that? When we talk about a living program, how better is it to be one click away? The work order that Doug just wrote, or Sean, introduced a new failure mode or an existing failure mode on this asset. I could put in a formula automation script check to see if that failure mode exists inside the RCM analysis. If that's in external software, you can't do that unless you build an integration. I'm saying, and by the way, no one else has ever suggested this before that I'm aware of. I'm trying to bring these two worlds together. Why haven't you done this? Okay, John.
Sorry, I always sound negative, but we've actually looked at it. So what happens, John, is your CMMS system is your highest controlled database at your plant, at your site. It has way more strict controls. I don't know if it's a common language, but we call it a quality control level A type system at our plant. All my stuff out there on the outside, my reliability world, is quality control level E. And in other words, it's way less expensive to maintain. Everything I try to integrate into my quality control level A system comes under a whole set of regulations and rules and stuff that makes it so expensive. I'm like, I'm never going to do that. It's ridiculous. So I keep them separate because it's cheaper. And I have control of my changes because I'm a level E type quality control program. I can make any changes by just calling a guy and go change it. Once it's in the CMMS system, I'm in the IT nightmare.
Okay, I appreciate that feedback, John. Really, I do.
Other plants may not have that issue, but definitely at ours.
I mean, I was 7 years employee at Grand Gulf Nuclear, scheduling supervisor. I know they're very strict. Not every industry, there's several reasons why roadblocks will pop up. The software tool itself is not configurable, number one. Number two, it can be rigid standards, difficult to change policies, or it could just be politics, number three. And there could be many more reasons. But sometimes, if we have permission to do so, if we can state the benefit to leadership why this would be helpful to create a living program, which I truly believe in, I believe I could sell them this. I'm not a salesman, but I think I could sell the leadership office on this concept. To create a new application, and we have people in the back, I have a number in my hand behind my back. How many days would it take to create a new application? 5? Yeah. Okay, I said 3 because I know you're better than that. Good stuff, Henry. Thanks. So using the software that I'm familiar with, it's highly configurable. So we just really, what's required here is a vision. I'm giving you the vision. So you made a good point. Hey, not every industry is nuclear, but I'm saying all of these other guys, they have options. I'm sorry. Yeah, all right.
I think we need to look at the CMMS as a tool. Hold on,
Good stuff, Carmen. She's coming.
I think that we need to look at the CMMS as a tool, and that the tool that will help us to go through our journey. What is happening, and this is my own belief, is sometimes we want to implement tools without having goals, without defining our journey, and that's when we have the conflict.
Well, there needs to be thank you for that. There needs to be a long-range plan, and it's just hard for me to show you everything at once that's in my head. I do have the long-range plan coming up, and I bet our time's getting short, but this is the work order matrix. This could be, in the HSE application, there's a, I forget the name of it, but you can create a work order prioritization matrix, X and Y parameters, and then you can put your BRE on this side, and then line that up with work types going across the top, and that can give you don't call it a priority value, call it a brand new gadget, which I'll call it ranking value. So it creates a ranking value, and you could have a midnight automation script that automatically ranks the entire backlog. It could be like 1 to 1,000. You could do anything, and that would be wonderful information for a T5 countdown scheduling process. Because you need the marching order not only for scheduling work, but let's back up. For the planners. The planners have a planning backlog, and then you have a scheduling backlog. So the planners could benefit from this too. Okay. Closing the loop. Root cause analysis, we did that. This is my feedback. Very few customers do this. Maybe you guys do, we'll find out. Work order feedback, which is maintainability issues, safety issues, ergonomic issues, energy efficiency issues, design flaws. You'd be surprised if you start asking the working level what knowledge they have. If you don't ask them, they're not going to tell you. There was a slide yesterday that had an iceberg on it, but the gentleman didn't get a chance to talk about it. But that's what that slide was about. The top of the iceberg is only a small amount of knowledge that the leadership team is aware of. Then you got this other knowledge below the surface of the water that no one's asking about. Actions performed. Shift turnover notes. You have a 24/7 operation. Shift turnover notes are extremely important. Actual man hours, most organizations capture that just fine right now. Actual materials, just fine. Service costs comes in on the PO linked to the work order. Failure mode capture, this is where we struggle. People put this off because it's too hard. This is critical for chronic failure analysis, which gives you a potential 40 to 60% reduction in maintenance costs. So you're live on your system, whatever system you have this very moment. What are you doing this very moment? Are you trying to make perfect specification data? Are you trying to load missing location and asset records? That's all well and good, but are you pursuing the shortest path to value? I can't think of anything more important than pursuing this business process initiative. Chronic failure analysis, which starts with accurate failure coding, including a failure mode definition. Okay, fine. Yes.
I'd like to add a comment on this.
Sorry?
Okay. I'd like to add a comment on this.
Anytime.
On chronic failure analysis.
Yeah.
I think what we should think as an organization is the cost of failure, okay? And even if it's a repeating failure just once, if there's a cost in it, we need to address it. And it's really the time it takes to devote people to actually analyze failures, because we should say that no failure is acceptable. Just like, and I have a t-shirt about that, just like in aviation and in nuclear, in some of those industry, no failure is acceptable. So as any industry, manufacturing or whatever, what you should think is, what is the cost of each failure? And then, is it worth it to have somebody, reliability engineer, that is hired to actually analyze all those failures and make sure they don't come back? It's a good thing to actually take the top 10, but if my top 10 are in the 100,000s, it's been a long time ago that I should have somebody full-time to actually analyze that and make sure failure doesn't come back.
Okay, I understand your point.
So it's really cost of failure we have to think about.
Go ahead.
Yeah, I would just like to say that our organization, using the classifications and things like that, we've actually accepted the fact that we're going to run some equipment to failure. Why do maintenance on something that is going to have a low impact to your business and at very small frequencies? We'll just run it to failure because I have more important, better hours to perform with my trades guys. So our organization has totally accepted that. And we do that with the classifications. A's I have to do, that's PS safety, whatever, major pieces of equipment that the line can't run without it. The mediums are ones that maybe we can bring other things in, handwork, things like that. And the C's are conveyors or pumps or, you know, we have redundancies. It doesn't matter.
Yeah.
You know, we accept that.
I think
That's exactly what I'm saying. So you go by cost of failures, and then some are acceptable because it's low cost, but anything that is higher cost, there is a benefit in making sure they don't come back.
the metric, okay, cost of failure involves more than just the repair cost. It involves collateral cost and other.
Production costs, everything. Yeah.
And even impact to environment and so on.
Yeah.
Public relations, yeah. So, but that should be quantified properly, if properly quantified with the BRE. And so I come back to, if that's in place, I can manage by exception. I know there's a desire, you guys are all wonderful people, the best in the class. You want to keep your hands on everything, but you're going to lose sleep at night if you try to worry about every asset. You've got to manage by exception and focus on the bad actors. If you do that, you will be doing the absolute best you can do every day. This is Pareto, Vilfredo Pareto. The best you can do every day to be working on the biggest bang of the buck. However you say that. That's my opinion. And I know there's different opinions. And I want to listen more than I talk. I try to. Okay. All right, let's move on. So this is the work order feedback, and we've covered this. You can get feedback on a PM strategy. The tech might say, you know, you got the wrong strategy in place here. Or he might say, you've missed a step, or this step here, the wording on it sucks. It's very poorly written by the planner. It's not clear. Or you left out a safety step. There's a hazard in the performance of this PM, and it's not mentioned anywhere, any precaution. You trying to kill me or what? All right. Asset condition, as we mentioned earlier. Ergonomic issues, which means like 3 Mile Island. So the gauge on top of the tank, you could make the gauge bigger. I bet you at the nuclear plant they did some things here and make the gauge bigger. Maybe you put some red color when it goes into a bad threshold area on the gauge. Red, green, yellow, whatever. Maybe you got too many gauges, like they did. And okay, design flaw. These techs right now know about design flaws in this equipment. You just got to ask them. Maintainability issues also, big time. Should we define that? Who can give me a good definition of maintainability? It's the ability to quickly diagnose a problem and or access the problem in trying to repair it. It can just be poorly designed mechanically. Before I forget it, I want to introduce Judy Bass in the back of the room. You've already met her, maybe outside in the hallway. She is a publisher. She's showing a list of books that she has published. And I tell you what, in your career, how many more years are you going to work? Another 5, 10? I'll bet you with the 20-some years you have worked, you have a few ideas. And if you could figure out how to put those together into an outline, that's your first step. All right. And then the next time you have some more time off, you try to put some more content behind each of the bullets. What this lady does is that she will take your manuscript and review it, and if it looks pretty good, like if it's a new idea that hasn't been introduced before, she will publish your book for free. Can you believe that? For free. And there's other publishers that want money up front, but if you want us to look at your book, you're going to have to pay me $3,000. Okay. Well, she gets professional editors involved, and then if the book starts, when the book starts selling, you get a percentage of the profit. Well, how bad can that be? All right. You want to add anything, Judy?
No, and then I go to lots of maintenance and reliability shows and sell them. Make sure that the word is spread.
Good. All right.
Hey, John, can I add one for you on the feedback there?
Oh, yeah.
The biggest one we use is we have the shops can challenge the PM.
Yes. I meant
I
to say
didn't
that.
see it in there. Maybe it
PM
was.
strategy, challenge it.
Oh, okay, that's what that meant. Okay.
Well, you want to give me an example?
Yeah, well, what happens is at the end of the work order, the shops have a set of closing screens that come up, and one of the closing screens is, do you want to challenge the periodicity this PM? You can say, you know, we need to do it more, or we need to do it less, and here's what I'm finding. And then that challenge board goes to the optimization group, and we'll consider it, and then we feed back to the shop and go, hey, that was a good idea. Yeah, we took this out.
The challenge, quote unquote, is that narrative text?
Pardon?
Is it text field? Is it handwritten or?
Yeah, they hit a field to tell us that they have a challenge, and then we go to a text field to see what they're challenging and why.
Okay, so you have an electronic workflow?
Yeah.
Okay, fine. All right, I'm moving on. Thank you for that, though. All right. This is chronic failure analysis, the whole process, 1 through 9 steps. First thing is to capture the functional failure. We discussed that. Capture the functional failure with the failure mode when the job's done. All right, and reliability team on a monthly basis will run the failure analytic, which needs to exist, and they'll pull up the top 10 bad actors, and they'll start looking at the list and asking questions. That's number 3, the asset offender report. Number 4, they will pick one of those top 10, maybe 2 of them. They'll click on it, and they will drill down dynamically on the failure mode, the 3 pieces, starting with the failed component. Click on one of the wedges, it goes to the component problem, and then to the cause code. Imagine the wealth of information in that meeting in the hands of the reliability team or the reliability engineer for them to start making value-add corrective action going forward. Very few organizations are at this capability. Number 1, they don't have a reliability team, and they certainly don't have the failure analytic in place. This is a 2-step design. Not only identifies the bad actors, but goes one more step and pulls out the failure mode, which you won't be able to do if you don't have the failure mode on the work order. Okay. Am I depressing you? I don't know. All right. Did I lose it? I think you can still hear me though. All right, so that's that. Thousands of organizations around the site. 70% of all sites have never done this process. I'm guessing, right? But I think I'm close. It's probably higher. So what's sad to me is, I know when this product first came out, we're talking 3 decades ago, I worked for the company, right? And they've never made a single improvement to the failure code hierarchy screen. Not one. I don't think they've read any books by Mowbray. All right. So 3 decades later, no improvements, and the conversation has never gone in the direction I'm discussing today. So without chronic failure analysis, yeah, we'll move on. So this is Winston LeDay, and it's in the body of knowledge that as CRLs we're required to read. And this guy here is one of my mentors, And he's big on defect elimination and creating shadow networks. So here's a piece of equipment. Lord knows what that is. But look at all the tags hanging off of that thing. And the little guy in the blue suit doesn't look too happy. And so who should do defect discovery and elimination? Well, you might have a defect team that once a week on Monday morning, the maintenance supervisor, maintenance manager allows this team to peel off, and they've got their liability engineer as a member, and they go looking at a particular critical system, and that day they're going to focus on that system. They might hang some tags, but and the best practice is if they can fix it right then and there, they're going to fix it. Now, where do they charge their time to? Well, they might charge to a blanket work order. You do not need to make a work order for each one of these minor defects. But the thing is, these minor defects can eventually cause larger problems down the road, and so you want to start going after that because no one else will. So operator, maintainer, PDM. Should have been CBT tech. Well, yeah, I got that. Defect elimination team, right? Okay, defect examples. So the operating procedure could be incorrect. You could have excessive rust, corrosion throughout the plant or on a particular system or asset. You can have broken indicator lights. Anyone have broken indicator lights? Okay, level gauges are working. Potential hazards, missing guard covers on belts. Yeah, excessive fluid leakage, oil leakage at the base. You could have soft foot. Who knows what a soft foot is? Okay. Pipe hangers missing, defective wiring, broken conduit, yeah, operating valves not tagged properly, sight glass broken, gauges too small, missing asset identifier, it's not even in the software, housekeeping issues, engineering design flaw. Okay, fine. Let's move on. So here's this slide, which John's not sure he agrees with, and I appreciate his thoughts there. But Winston Leday says 4% due to aging, 12% due to wear and tear, but everything else falls into human factors, which is the careless category, and that breaks into a subgroup. So you can have raw materials that actually cause the problem because they weren't a proper quality. Operating equipment, the procedures or operator was operating the equipment incorrectly, and that's actually the highest percentage in the subgroup, 29. Workmanship, you know, that's our maintenance techs. You can induce failures doing a PM. Incorrect inferior parts and design flaws. Human error is inevitable, but if we ignore it, it can cause bigger problems down the road. So defect elimination, and fine. Now this Winston Leday guy, he let me get back. He breaks it into 3 domains. And there's a reactive domain, which most organizations are in right now. Doug, your site, are you able to answer? Are you in a reactive domain?
Very much so.
Okay. He made a bold statement here. He's not afraid of embarrassing himself, but he's saying that he's in reactive domain, and I'll bet you there's others in the audience, right? Okay. So some leadership teams believe, well, if we could just implement more PMs and get that going, we can get stable. Winston Leday says that's a flawed concept. The reason is, yeah, you will start generating a heck of a lot more monthly PMs to do this and that, and perhaps minimize some defects, but you still have the things that are causing the reactive breakdowns occurring. You haven't eliminated that. So now you've got more work than you've got staff. And that's called an unstable domain. And there's a good chance 6 months later, leadership will get upset and start asking a bunch of questions and asking for change. The precision domain is the only stable domain in the mind of Winston Leday, and I'm going to show you how to get there. Okay, so the reactive domain, you have in red a lot of breakdowns taking place in general repairs. The breakdowns are more serious events on critical equipment and cause operational damage. Okay, And then in the plan domain, you have reduced the breakdowns a little bit, but you still have general repairs going on, and now you've introduced the blue and the yellow. You have a lot of PMs taking place, as well as the condition-based technologies, and now you've exceeded your manpower threshold. So the troops are doing overtime, which they might like, I don't know, but you're really busy, and that's why it's called an unstable domain. Okay. Now, if we can get to the precision domain where we implement defect elimination, we can start performing a lot of defect discovery and elimination. Some of them become work orders depending upon the magnitude. You have breakdowns still occurring, but at a reduced pace, and then you have some PM taking place. But precision 2 domain is where everything is where you want it. So your defect is ongoing, breakdowns are reduced, general repairs are reduced, PMs are stable, and your condition-based technology is your largest body of work. That's the precision 2 domain. All right, this is the last slide on defect elimination. So a typical site has whatever availability. In this slide, it's saying 83% The story goes, if you implement planning only, not scheduling, but planning only, you will get a 0.5% increase in plan availability. If you implement scheduling only, you'll get a 0.8% increase in availability. If you implement preventive and condition-based technologies only, it actually decreases due to the requirement to take stuff out of service. If you do all three tactics, you will get a, don't try to add the black numbers together because that won't work. This is just the way the study worked out. They say you get an increase of 5.1%. Now wait for this. If you do everything as a holistic approach, that's when you get the largest bang for your buck, and that's the 19%, 20% gain when you implement, in conjunction with everything else, defect elimination. That's the whole point of that slide, trying to explain the significance of defect elimination. Do you have defect elimination teams at your site?
Yeah.
When did you first discover about defect elimination?
It's just something that cool us, you know, some our single point vulnerability analysis. We have a whole single point vulnerability analysis
Team. I can give you some war stories on it though.
Give me one.
I'll give you one. We went to a new Genrex system on our generators. Super whammy dying, better than the other one, eliminated a ton of single point type vulnerabilities that would take the plant down and lose production. What we didn't realize was we added a bunch of them that we didn't realize. And so now we got that set taking us down. And we have run into a number of maintenance issues when we install the things that have taken us down. It's actually hurt our reliability overall. And there's a lot of plants out there that have that story. They go to this all-knowing defect elimination and the maintenance-induced errors from putting it into place, which would actually follow what Winslet was saying there, is actually causing more problems. Now, maybe after 5 years we'll have it all figured out and done, but I can give you negatives too.
Okay.
But the idea is right. The idea is you do want to do it. You know, if you could execute it better, I guess.
All right, thank you, John, as always. Would you admit this? I don't know. Is there anyone in the room who honestly was not aware of the two words defect elimination before this session? Oh, okay. All right. All right, let's move on. I love this subject there. So, hey, there you go. There's a roadmap. I know you can't read this, but it's in the presentation handout, so you'll get that electronically in the PDF format. But this might be the collage you put on your wall or your whiteboard. And when you see the executive level walking down the hall, this is how you begin your conversation. So it starts with the notification, goes into a work order, the planning and scheduling. Sometimes you have shutdown work that needs to peel off. Sometimes it's dispatch, urgency dispatch. And then we can get into a T4 weekly schedule countdown. This is very advanced scheduling here. Some don't even have a weekly schedule. And then most importantly, on repair work order, we capture that feedback, and that's down there at the bottom. Yep, there it is. Okay. Busy slide. Reactive maintenance. Yeah, first of all, you should have a definition for what reactive maintenance is. What's the SQL to pull that puppy out? Oh, yeah. You don't need to become SQL programmers, but you got to start thinking about this. Is it your high priority work and it's interrupting the schedule? Is that your reactive maintenance? Is it work that has a functional failure only? So, yeah. My definition is it's emergency and urgent work because it's breaking and because it's a major event that was unplanned. And it could be self-induced interrupt. Self-induced. This is a term from Doc Palmer. And even though it's not absolutely critical, the operations manager said, I want you to do this work this week. Self-induced. All right. That interrupts the schedule. So how do you, 10 ways to reduce reactive maintenance. Well, track it using your definition. Set up for risk-based work order prioritization using that matrix I mentioned earlier. Evaluate the scheduling function. Get the scheduling process in place, planning and scheduling. Document a formalized RCA process to go after those catastrophic events. Then chronic failure analysis, my favorite subject. Reliability leadership team roles. Get that failure analytic written. Defect elimination teams. Formal work order feedback. Okay. This is, there she is over there, Nancy. And this is what she does. She has a software proprietary package perhaps that stores this data. When she conducts the workshop and the interviews, this is the information she records. So you start with the function, functional failure, and you get into the failure modes. This is RCM analysis. And then just more of the same and more detail. Yep, okay. So, majority of all sites have been maybe collecting high-level basic failure codes, but they're not of any value to the failure reliability engineer. Okay, yep, that's fine. This is another mentor of mine in addition to Nancy. This guy's Douglas Plucknett. He wrote a book called RCM Blitz. And so he okay, hold on. He was discussing the failure mode, and he immediately broke it into 3 pieces. And what did I do? I'm thinking, as a CMMS guy, can I take those 3 pieces and put them on the work order? And I did. All right. That's the gist of that. But he gave me the idea by reading his book. And you also can get a lot of ideas going forward by looking at some of those books out there on the book counter, right? So, benchmarking. Okay, this is the standard, and the next page. Look at all the yellow. You can see the yellow maybe from the back of the room. The yellow is hitting on the word failure mode. Look how often it hits in the body of this document. Failure mode, the language of RCM. Okay, I love this cartoon here. So here's an operator. He's operating a very large drill press. You can see the back of his head. He's got a little bit of hair on his head like me. But the machine stopped. Machine stopped, and he's figured out that the overload breaker tripped. Well, you can see the breaker. It's right there on the wall, and it tripped. So is that the problem? All right, so number 2. Now he's moved to the other side of the machine, and he's scratching his head now. Why did the breaker trip? Well, it looks like there's insufficient oil on the shaft. Somehow he's figured that out. Okay, and why did that happen? Well, the oil pump is not at capacity. He knows what speed it should be running at and the sound of it, and he knows something is wrong there just by listening. And why is the pump not at capacity? Well, the pump drive shaft is worn. Well, now he's getting frustrated. Well, why is the shaft worn? Well, the oil filter was blocked with swarf. And that's those thin, curly metal shavings, you know, and it's blocked the filter, which he was supposed to clean the filter at the beginning of the shift. But he didn't do that. All right. So, but what am I really after here? In the software I use, the out-of-the-box product, it captures the asset. And it captures the asset problem stopped. And the cause code is tripped. And that's where it stopped. that's the gist of the failure information on that asset. Well, if I'm a reliability engineer, that is not good enough. Now, I'm not saying we got to do a root cause analysis, but we need to get more of the story on this screen. So down here at the bottom, the component is the oil filter, the component problem is blocked, and the cause code is operator no clean. Okay, those are invalidated fields, and we can track the number of times that occurs, not only on this machine, but maybe on others. And that makes great data that can be aggregated to make better decisions from. These are examples of failure modes. So on a belt is worn due to abrasion, belt fails due to misalignment, belt fails due to improper installation. The shims can get worn sometimes and cause belt replacement at a too infrequent frequency rather. Okay, so those are examples of failure modes. All right, fine. We did this, fine. It's my opinion that, I mean, you have a lot of components in every asset. I believe the components themselves will sometimes overlap. So I'm not going to go with specific components for a specific asset or asset class. I'm just going to put it in one large list. That's the purpose of this. So the red circles indicate similar components across different assets. This is the trying to demonstrate the type ahead feature. So here's the failed component at the bottom of the screen, right down here. And the moment you type one character, this list instantly changes. Even though there's 500 entries, it only pulls up those entries that have that one character. I type a second character, the list changes again. Type a third character, it could be anywhere in the word, by the way. It doesn't have to be at the front. And it will hit on that precise word. It's an excellent use of that design. Problem codes, fine. Failed component, cause code. Cause code is the absolute hardest thing to get. But if you don't get it, there's a good chance that bearing is going to fail 9-12 months from now on the same asset if you don't eliminate the cause. Oh, this here is a great slide. I think I got this from Douglas Pucknett, and he calls it the sawtooth. So sawtooths, right? Yeah. And so you might detect the darn thing with the condition-based technology, and you get really good at it. But if you don't eliminate the cause, by gosh, by golly, it's going to occur again 6, 9, 12 months later. SQL, select. This is like English language to me. Select top 10 assets, count. Show me the count of work orders for the same asset from the work order table where functional failure equals yes. Functional failure is that brand new field we added. Group by asset number. And you do that and you get this. Come on. Oh, this thing here. You get that list right there. So that asset identifier, MFT07, had 1,300 and some hits. This is going back, for this one site I did this at, I did not put any time restraints on it, so it went back 10, 15, 20 years. So that's why the numbers are so high. Okay. This is what a work order entry screen might look like. There's my functional failure right there. Okay. Once that's in place, then it's electronically mandatory for the failed component to be entered by the tech. When he goes to complete the job, number 4, he's going to enter the failed component. If it's not there, I have a missing component to the right. He's going to put in the component problem, validated field, cause code. I put the cause code, now this is going to be hard to follow if you're not listening closely. Here we go. I put the cause code into 3 levels, but I'm only showing one here on this, one at a time. So cause code 1, is it a defect? Well, is it due to aging, wear and tear? Was there a power surge? Is it a housekeeping issue, environmental issue, force majeure, a tornado, hurricane, car ran into your living room, I don't know. But if it's not any of those, then it's something else, which is a polite way of saying human factor. Here we go. So if the tech simply answers one of those 6 or 7 choices in the orange block, that's all I want him to do. And he's done. Now, the cause code 2 field, this work order is routed to the maintenance supervisor maybe. It's however you want to set it up. So now it's on the maintenance supervisor's desk, and he's got a different choice set here. Was it due to, it's a human factor, is it due to a vendor setup issue? Is there a design flaw? Defective material part? Are the procedures wrong, either operational or maintenance? Incorrect PM? You know, this is a monthly PM. It's supposed to be done looking back at the last 6 months. I can look at the history, and it was skipped 3 times out of the last 6. When you have a lot of reactive maintenance and the trades get busy, the supervisor will come in there and he'll just outright cancel that PM work order. If you give him that authority, he will. Because they've got, you want me to fix the fire or not? Or you want me to work on this PM? You decide now, make a decision. Fire, PM. Okay, so you tell him to go fix the fire and the PM gets canceled. Now, if this PM is a monthly PM and it's over a 6-month period, it was canceled 3 or 4 times, whether or not there was reactive maintenance, it might tell you other things, but that in itself could be the cause for this situation. Moving on. Cause 2 is that if it's workmanship, now we are zeroing in on the maintenance craft. I don't know how else to say it more politely. We're zeroing in on the maintenance craft. Was there an installation error? Improper tensioning, improper mounting, misalignment, imbalance that was induced, incorrect fastening, induced vibration, equipment distortion, lubrication, incorrect policies, failure there, and induced contamination. There could be other words, but this is a good start. Is it easy to get this information? No. But I'm not asking you to do a root cause analysis, but I think we can get a lot closer than nothing. Easier said than done. All right, capturing cause codes, we did this. I did that, fine. And sometimes for highly critical equipment for a major event, shy of an RCA, you might want to have a closed door conversation, maintenance manager with the tradesperson, and you just, how you going, Bill? And what were you thinking when this occurred? Did you have some problems at home, or are there money issues? What's going on? And so it gets into human factors, it gets a little bit personal, but you might discover at the end of the conversation that there was a lack of knowledge, a skill set, precision maintenance-wise. Now, you don't want to embarrass this guy, so you say, thanks for your information, the feedback you gave me. I'm going to set up a precision maintenance training on this one subject for the whole team, the whole crew, so I'm not going to single you out. And that's one way to pursue this. I may be near out of time. How are we doing, Nancy?
Honestly, my watch broke today. You got 34 minutes.
Oh, aren't you lucky? All right, good. All right, hey, this is the metric I discussed earlier. It's called, I think it's the most powerful metric out there. It's, you can call it whatever you want to call it, average annual maintenance cost divided by RAV. It is one of the British standards. It's there. It's their #1 economic key indicator. And, all right, average annual maintenance cost divided by replacement cost. So if you haven't populated the replacement cost, that math will not work because you can't divide by 0. That will fail immediately. All right. You could, for those who know SQL in the room, you could do a isNull or NVL function and then put / purchase price, which you normally have. They would take that instead of replacement cost. All right. Fine. This is the analytic. I may stop here. I'm going to stop on this slide. This is a very important slide, and we'll stay right here. The failure analytic, you might get a group of people together and design what works for them. I think this is a great example if you want to start with this. So the person who runs the report, you might run it the half hour prior to the meeting. It might be your business analyst, might be the IT guy, it might be the reliability engineer. So run it in advance of the meeting, print out some copies maybe, so you can anticipate the conversation. But when you get into the reliability team meeting, you still want to have it on an overhead projector because we can dynamically drill down on the failure modes. Okay, so you answer the prompt, how do you want to sort this report? Because you can do it different ways. You can do it on the number of functional failures for that asset. You can do it on mean time between failure. You can do it on asset condition. You can do it on downtime. And you can do it on my favorite metric, which is the average annual maintenance cost divided by replacement cost. And the last one is what? BRE itself, which is sort of useful, sort of not. Or you could add a new blue down arrow, which is BRE times asset condition, which I mentioned earlier. That's what I would do on that last one. So once you decide that, that's the first prompt. You could answer a second question that says you have a particular system in your plant that's problematic, you want to focus on that only, and then run this report, and further filter it. Okay. You could go after a particular asset classification. You could even go after a manufacturer there, number 7. Yeah. You could do a date range. All right, so you run the report, and you click on this asset at the top of the list here, EN0012. Click on that guy. And now a pie chart suddenly appears on the right side of the screen. The pie chart is showing the failed component, which came from the work order. And whatever wedge is largest, you would take the clicker and move the mouse and click on that particular wedge, or a smaller one if you want. But let's click on the largest green wedge. I'm going to click on it right now. Is that amazing? All right. And then it brings up the component problems. And now I'm going to click on the largest wedge for the problems. And now I see the cause code. There you go. Reliability team. This is how software should be set up to make more informed decisions. This is how a CMMS should be designed, and no one else is talking about this. This is how you can perform chronic failure analysis, which gives you the largest potential cost reduction, cost savings for your plant. When you want to capture the attention of the plant manager and other executives, you talk money, and this is the tool to get you there. If there's a better business process initiative out there, I don't know what it is. Scheduling is very close, but I put my money on this thing right here. I think I'm done. Let's see. Oh, here's what I want to ask you. I lied. I have one more slide. That's a roadmap. Okay, I'm going to put you on the spot, maybe by table or whomever is brave enough to raise their hand. With the information you've learned this week, going back to Monday and Tuesday and now Wednesday, with the new information you've learned, the new ideas you've acquired, what might you do when you get back to your site in relation to taking a stand for reliability? What might you start investigating? What might you do differently? How about this first table? I'm not giving you much time to think about this, but... Oh, here she comes, here she comes.
For us, it's the planning and scheduling module. SAP has that, but
Yeah.
it's difficult.
Yeah.
SAP is very difficult with pulling reports and this and that, but that scheduling in the back that we've seen, that's probably something we're going to go after.
That's a great answer. Way to go, Sim. All right. Anyone else? Let's go to the next table there.
No?
Can't think of anything right now?
Anybody have any ideas?
Okay. All right, let's go over there.
I guess for us, it's just getting a reliability team. Some people just to focus on what we need to do moving forward with whether it be condition-based monitoring. And one thing you mentioned, so the defect elimination, having a defect elimination team. thought that popped into my head was just TPM. So total productive maintenance is I don't know. It seems like the same thing, but having operations kind of mesh with maintenance to kind of help identify those defects before they happen, because those are the people who are running the equipment, who are really close to that. So when they can identify and help the maintenance team to identify and create those work orders before they fail as well.
Great answer, and you are correct. There's a lot of overlap with a lot of acronyms. TPM, defect elimination, ODR, operator-driven reliability, Kaizen, and autonomous maintenance. You know, where do you draw the line? But they all sort of come together, huh? Yeah, good one. All right, how about the table right there in the middle? What one thing might you do differently?
One of the things that I was thinking about doing is just kind of going back through the assets and kind of the criticality is like an ABC indicator type deal, because we have SAP, and kind of just go from there, and then, like you said, try to see what we spent as opposed to what it cost. So that's what I'm going to do.
Good stuff. Is anyone here thinking about that asset condition concept that I mentioned? You could add that to your monthly PM, and you'll need to come up with a grade level, 1, 2, 3, 4, 5, or whatever. Then they're going to ask, well, give me some descriptive for each. It wouldn't be hard to implement. Then in the software I use, we can set up a characteristic meter, and then, so if you enter that data, it chronologically links it to a transaction table along with the date and the value, and therefore you can trend it over time. Okay. Well, I'm good if you're good, and thanks for your time. You've been a great audience.
So,
Oh.